Yeah, thank you.
Welcome.
Thank you, sir.
Welcome. Okay, so today I have some good topics to cover. I want to cover estimating equations for linear regression. That's one topic I want to cover. Estimating equations. எங்கேருந்து வந்து அந்த எஸ்டிமேட்டிங் ஈக்குவேஷன் எப்படி நமக்கு அந்த பாராமீட்டர் எஸ்டிமேட்ஸ்லாம் எப்படி வருது அது உங்களுக்கு ஓரளவுக்கு தெரியும் சொல்லியிருக்கேன் நான் but still I want to explain that and then go through an example. Second topic I want to cover is the total variance being split into two parts, model variance and error variance. That is another second topic I want to cover. Third topic I want to cover is R square and adjusted R square, okay, which is called goodness of fit. Okay, the fourth topic,
Goodness of
yes, R square and adjusted R square, which is called goodness of fit for linear regression. The fourth topic is how to predict using the model. And the fifth topic, which I don't know whether I'll be able to cover today, is diagnostics for developing a good model. Right? Those are 5 topics I have today in my plan, but I don't know whether I'll be able to cover everything, you know. So most likely diagnostics may not happen today. It should have been happening today, but because of last class, I know it's getting postponed. So what we did so far is I introduced you what is meant by a predictive model. Can anybody tell me about it in one sentence? There is a precise mathematical definition I gave you. What is meant by a regression model? What is meant by a predictive model? மறந்து போயிடுச்சா சொல்லுங்க.
Regression model means we have to find a relationship between independent and dependent variables. So predict that variables based on dependent variables. So that is the regression.
Yes.
And modeling means based on there is more modeling is there. Based on modeling, we have to find out that forecasting and
I'm sorry, Riaz came. Yeah, I said Riaz. Hi to Riaz. Okay, go ahead. Sorry, go ahead. So there is a very key sentence நீங்க அதை விட்டுட்டீங்க. எல்லாம் you are எப்படி யூஸ் பண்றதுன்னு சொல்றீங்க, என்ன பண்ண முடியும்னு சொல்றீங்க, பட் அது எப்படி வருது, what defines the model அப்படின்னு சொல்லணும். அது சொல்லுங்க. What defines the model? How is it coming out? But how you are using, how you are going to use it, how they are related, அதெல்லாம் சொல்றீங்க. You are telling, but how is it coming out? What there is a fundamental mathematical statistical principle there. Anybody wants to say that? 2 words.
Based on sample variable.
I'm sorry. Say that again. Sample variance.
Sample variable.
variance total variance வந்து population வச்சு கண்டுபிடிக்கிறோம்.
Total variance explain பண்றோம். That is again, you know, a way of explaining the what
group
is
data.
Grouped data.
Group data வந்து group dataல இருந்து எடுக்கக்கூடிய அந்த variance வந்து எடுத்துட்டாங்க.
So relationship about the variables.
That I said.
2 very interesting words which you know it only in statistics.
Slope and intercept.
Slope and intercept is a linear form. சொல்லுங்க விக்னேஷ்.
Okay. T value and T value.
That is about whether how good the variable is. I am asking what is meant by regression. ரொம்ப சிம்பிள் அழகா சொல்லணும்.
Finding the relationship.
Finding the relationship, of course, finding the relationship, which Vijay also mentioned. But there is a two critical statistical term that explains what it is. And when I taught you, I said that estimating the relationship, that's fine, but still, I said these critical words, a sentence I told in the beginning when I introduced the topic, and I said I will also ask you this in exam.
Conditional mean?
Excellent. That is
It's a
it.
conditional average.
Yes.
Conditional.
Conditional mean,
Conditional
conditional average, conditional expectation, எல்லாம் ஒரே meaning தான். Conditioned on the specific values of the independent variable. Right? That's why it is written in this way. I'm going to, that's why it is written. One moment. I'm going to go to page 49. Let me go to page 49. அதுக்கு முன்னாடி போட்டுருவேன். So this is diagnostics. Estimating equation is by 89. Okay, so is everybody with me? Everybody buys that idea, right? Understands and appreciates that, right? So I always said that is why, not the ink, I don't want the ink. I want to insert the equation. Actually, I did that, insert the equation somewhere. The equation. So it's a conditional expectation, right? Because our conditional average, you can say any number of ways you can say that. Okay, so I'm going to write it like this again. Y, small y, capital X equal to X. Isn't it? Everybody agrees with this?
Yes.
This is called conditional expectation.
Yes.
In fact, I don't know why people don't say this in a very crisp way like this. PhD படிச்சவங்க கூட இவ்வளவு டக்குன்னு சொல்லிட மாட்டான். ஏன்னா people, you have to repeat this yourself many times, then only it will stay. In a tense conversation or an interview, people cannot recall this immediately. தெரிஞ்சதுக்கு அப்புறம் இது சிம்பிள் சொல்லுவோம், தெரியற வரலாம் அது. It is hard, right? And the connection you make, because I keep on telling that is what it is, that is what it is, that is what it is. It makes it easier for you to remember also. In fact, when somebody interviewed me, I think I told you in this class, when somebody interviewed me, they asked, okay, what is regression? I said, it's a conditional mean. I mean, that lady was expecting me to say something else, because it is very difficult to explain otherwise. That's another problem. It's very hard to explain. You can say, you will explain all these things like, it's a relationship between independent variable, dependent variable. You are talking about it is as, whether that relationship is linear or non-linear. You say this, and the reason why I'm saying this is, I see people are not very clear about this. Even your interviewer may not be clear about it, but you have to say, yes, it is. And you explain that. How will you explain? You remember the basic simple income gender equation I talked about? You remember that?
Yes.
And in that, what did we do? We have only 4 observations. Okay? And two male and 2 female observations. And then by putting the X equal to here, and in that one, what we did was this. I was trying to calculate conditional expectation of income given. We say this as a given, right? This vertical symbol is called given, right? Given, or given the subpopulation is males. That's what I did, right? And like that, we also did this one, conditional expectation of income given the subpopulation is female. That's what we did that, right? Isn't it?
Yes.
And in more explicit symbol form, we did this. Income given gender is male, or you can say sex is equal to male. No, it doesn't matter. In other words, the other one is this one. Gender equal to female. F means female, M means male. This is what we are trying to do. And what is the one beautiful conclusion out of this? That I hope you remember that. That is what gives us the confidence why this is a better equation to predict. There was one conclusion I made with that small example. Do you remember that? The predictive, the variance of the predicted values has less error. You remember that? If we use the conditional expectations instead of remember that overall average, exactly. In other words, you can say overall average as the prediction, right? But if you don't do overall average, but you do the conditional average, conditional expectation, then the prediction is less error in the predicted value. What does that mean, less error in the predicted value? Let me explain that also again. Instead of overall average. Okay. Now what did I say? I'm saying, okay, I'm going to make it smaller in size. You are able to see the screen, right? You are able to read this?
Yes.
Okay. So condition average. And what we were saying is that what is meant by error here? Prediction error means what? It means original value minus predicted value. That's what the predicted error is, right? Is it? I mean, are you with me?
Yes, sir.
This is what we meant as error. So this part, then you are able to connect with the person with whom you are talking. Okay, very important, very basic, very important. So you are expecting your model should give less error compared to the overall average. Very, very important. Otherwise, what is the use, right? You as well use the overall average. Why bother modeling it, spending your time explaining it, and so on. Okay. Now, I said I want to go to talk to you about two things before I go to the how to predict using the model. Okay, and then diagnostics. Okay. So how do I? So go ahead.
How to read that formula?
Say it again. I'm not able to understand what you're trying to say.
It is the conditional expectation of income based on gender also.
Given, yes, yes, based on gender, given gender, but I think given is lot more clarity. It has lot more clarity. The moment you say given, you are subsetting the observations, right? So use the word given. That's a better word. That's a more commonly everybody knows. Okay.
Sir, I have one more doubt, sir.
Sorry.
Sir, instead of giving a single value as a prediction, why can't we give a range, sir? That will again reduce our error rate.
Very good point. In fact, statisticians have created confidence interval on the prediction. But that's koncham advanced. So what they will say is that, no, look, men income is between 45,000 to 55,000, right? Then you are more likely to be, and they will say it is 95% confidence interval. You see how we defend ourselves? Yes, you are right. It will know. You will always say, look, I already told you it is 95% confident. It is any number between these two range values, right? The minimum and maximum. Yes, of course you can do that. And your output will also print out the confidence interval for the predicted value of the individual based on the individual characteristic. Okay, but little bit advanced. But as long as you understand this, your next step is definitely true, and we can achieve that. Your software will also give you that output.
Okay.
Okay, but நீங்க நல்ல கொஸ்டினை கேட்டீங்க, அதை எழுதி இருந்தீங்களா நான் சொன்ன ஆன்சரை?
புரிஞ்சுது சார் எனக்கு. நான் எழுதிக்கிறேன்.
இல்ல it's knowing one thing and becoming that is another thing. Gandhi said it is not enough to know, you have to become. One way to become of what you know is think, write, speak the same, right? ஏன்னா நான் உங்களை போல தான் நினைச்சுட்டு இருந்தேன். I used to say that எனக்கு புரிஞ்சு போச்சுன்னு அப்புறம் மறந்து போயிடும். Okay, I hope you don't mind if I talk like this, because it's all my sufferings. You should not suffer that. Okay, all right, so
yeah.
Okay, now any other question? We need to move to the next the important point that I wanted to bring it to you. Anybody else has a question? Ponwani and Riyaz, Satish, who joined later.
No.
Okay. So I'm going to go to now estimating equations for regression 89. One moment, please. So you remember this one, the sample example நான் கொடுத்தது ஒரு 5 பாயிண்ட் வச்சு நம்ம போட்ட ஞாபகம் இருக்கா இந்த எக்ஸாம்பிள்?
Yes sir.
Okay, so this is the way it is now. You have a y value, there is a x value, there is a error. So the a and b determines the best value. A and b determines the best value. A and b determines the best value for the given 5 y value and x value. That's what I'm trying to say. Okay, and that's what we want to determine also. Okay, one moment, I have to group them together so that I can move around together or make it bigger so that you can see it easily. Oh gosh, okay, I cannot do this. It's not easy. I can do it this way, then it becomes easier. I'm going to take this out. Is it okay? You can see it better now, right?
Yeah.
I'll keep these things in another page, and then I will do the same thing here. You remember we did it visually. So this is the model. This is the mathematical model. Okay, how we are mathematically structuring it. Y is a function of, y is a linear function of x1. That's what this part means. And then there is an error component to it. The actual y1 is predicted y1 plus error 1. Actual y2 is predicted y2 plus error 2. Are you with me? That's what this means in English. Actual y3 is predicted value of y3 plus the error associated with that value, with that y3 value. This is actual value of y4 equal is predicted value of y4 using x4 and plus some error. Okay, the error will not be 0. We know that. And in matrix notation, this is what we wrote, right? So the question is, how do we get A and B? What is the method that happens? What is the mathematics behind it that gives us this value A and B most accurate form? We did it visually like this, if you remember, right? We did it visually like this, but we are always looking for most accurate. That's where the mathematics comes into play, isn't it? So the mathematics is useful because it can give us the best answer without any error. Okay, so this is what our visual model was this one. Y is equal to 2 plus 1x. The 1 is the slope coefficient, 2 is the intercept coefficient. Okay. So what happens is that I need to go to the page. These pages are a little bit, I arrange them as I talk with you, but then I will rearrange them finally for you before we end the course, okay? In a better order, because as you ask questions, I change the order. What can I do? But no worries. Okay, one moment. I'm looking for estimating equation, page 89. That changed, I guess. That's the problem. Here it is. Okay. You all know how to find minimum of a function or a maximum of a function? Everybody knows that? In engineering, you are taught that minimum of a function and maximum of a function. Anybody who doesn't know that? Nagaraj says he knows, Vignesh says he knows, Vijay says she knows.
We don't know.
Huh? Don't know வா? கையில் எடுத்தவங்கலாம் don't know வா? நல்லா இருக்குது. Don't know முதல்ல சொல்லிடுங்க. I knowன்றதை சொல்ல மாட்டீங்க. Okay, fine, that's fine. So we'll go through, but see, here are the issues, right? I have to go through all those foundations little by little by little. It takes a lot of time, okay? But let's figure this out. Here is a simple example I'm going to share with you. Do you see this one? This is it's a quadratic function, quadratic parabola. Everybody agrees with that, right? தெரியலன்றது நல்லா சொன்னீங்க. தெரியும் போது சொல்லணும். இது ரொம்ப சிம்பிள். இது தெரிஞ்சிருக்கணும் உங்களுக்கு. ராமசாமி உங்களுக்கு புரியுதா நான் சொல்றது? This is a quadratic function. உங்களுக்கு நீங்க என்ன, what is your background, Ram? Business or engineering?
Physics, sir. Chemistry.
Physics, chemistry. Physics.
No, arts, sir. Physics.
Physics, MS.
MSc Physics.
Very good, excellent.
Master of Physics, sir.
Very good. So you would have known this quadratic function. Mathematics கட்டாயம் கொடுத்திருப்பாங்க உங்களுக்கு, calculus சொல்லி கொடுத்திருப்பாங்க. Yeah. So this is the quadratic function. Yeah, quadratic function. What about Vijay? Business உங்களுக்கு இது arts. But உங்களுக்கு mathematics இல்ல. But math you would have done it, right? Did you do calculus?
Yeah.
The quadratic function எல்லாம் தெரியும் இல்லையா? Square term, polynomial ரெண்டாவது square term இருக்கிறது quadratic function. Linear functionல square இருக்காது, வெறும் x தான் இருக்கும். அங்க x squareம் வந்துரும் quadraticல. என்னப்பா சதீஷ்? உங்க பேக்ரவுண்ட் என்ன? கம்ப்யூட்டர் சயின்ஸ். ஸோ உங்களுக்கு பண்ணிருப்பீங்களா மேத்தமேட்டிக்ஸ், ரைட்? கால்குலஸ் பண்ணிருப்பீங்க. கால்குலஸ் பண்ணிருப்போம். ஞாபகம் தான் வரமாட்டேங்குது. தானா ஞாபகம் வரமாட்டேங்குது இல்ல? வேற ஒண்ணும் இல்ல. பட் தி பாயிண்ட் இஸ், இப்படி ஞாபகம் வச்சுங்க, u versus inverted u ரெண்டுமே குவாட்ராட்டிக் ஃபங்க்ஷன் தான். u form and inverted u form ரெண்டுமே குவாட்ராட்டிக் ஃபங்க்ஷன். The only difference is இது வந்து the coefficient of the x square, right? that term tells you whether it is going to be U form or inverted U form. The coefficient of x square will be negative for the U form. Okay. I'm sorry, one moment. Coefficient of for the inverted coefficient will be negative. For the inverted coefficient will be negative. For the U, not the inverted but the regular U form, the coefficient will be positive. That's a simple way of determining. But the more important thing is, the minimum is occurring here. In this case, -1, 4. Are you able to see this one? Let's see. I'll make it a little bit bigger so that easier on you. I just copied and pasted these functions so that I can talk to you. So this function is x minus. You can also write it like this. There is a trick to it. Why how I figured that out immediately looking at the graph. I know the minimum point. From there I can figure that out. Okay, y plus 4 equal to x minus 3 square. That's what this means. Are you with me? You know why? Because when I put x equal to 3 here, this becomes 0, right? So y becomes -4. So this value 3 minus 4 is a point on the curve. That is clear, right? And that is also minimum, I know, only because I plot some of these points and then I see that no, it is a U curve and it has to be the minimum. Are you with me? There are other mathematics you can do to find out whether it is a minimum or not. That's what this is about. This is the way you find out minimum and maximum for a function. This is the way you find out minimum and maximum for a function. Everybody knows derivatives? Everybody knows derivatives? Yes? Anybody who doesn't know derivative here in this group? Derivative means basically the rate of change of the function. How the function changes is the derivative. Okay? The second derivative is how the rate of change of function changes. That is also called velocity in the speed equation. Second derivative is the velocity. First derivative is first derivative, which is acceleration, which is velocity. Ram. நான் வந்து அனலிட்டிக்ஸ் தானே படிக்க வந்தேன் இவரே இந்த கேள்வி எல்லாம் கேட்கறேன் இல்ல அது ஒண்ணும் இல்ல sometimes when we dig our mind response, our brain response. Okay, close பண்ணிடாதீங்க. Let's not close it. It's hard, I know. Okay, sometimes it's so long you did and then that you did 10,000 things at that time, or maybe 15 subjects, 20 subjects you did, and this is only one subject. So, tell me. Okay, speed of the first derivative, the point is this: first derivative equal to 0 gives you where the minimum and maximum occurs. That is also called 0 of a function. First derivative equal to 0 gives you, please write it down, first derivative of a function with respect to that variable, the function variable, right? What is the function variable here? X. Okay, the first derivative gives you first derivative of the function with respect to the independent variable equal to 0 gives you the point at which the minimum and maximum are attained. But then you don't know whether it is maximum or minimum. You need the second condition for that. You take the second derivative and evaluate the second derivative value at the first derivative zeros of the function. There are three terminologies I am bringing in here. I am bringing in three terminologies. Zeros of a function. Please note down what is meant by 0 of a function, what is meant by first derivative, what is meant by second derivative, what is meant by minimum, what is meant by maximum, how first derivative and second derivative together helps us to find the minimum or maximum. Are you with me so far? So many things I am defining for you. Okay. So what is meant by zero of a function? Zero of a function means that function equal to zero. That's not what I'm talking. The first derivative, the zeros of the first derivative of a function is the one that we care. Zeros of a first derivative. Zeros of a first derivative is what we care for to find out maximum and minimum. Okay. Now, what does that mean? It means take the first derivative and equate it to zero and solve that equation. Are you with me? I'm just giving a rule. Okay. The first derivative is zero, gives you the various points at which the function is attaining maximum or minimum. And now you calculate the second derivative, and if it is negative, you are attaining maximum. If it is positive, you are attaining minimum. Are you with me? It's just a rule. Don't worry about it. Okay. First derivative, second derivative. Riaz, what do you think? You know, what is your background, Riaz?
Computers.
Computer science. நீங்க உங்களுக்கு calculus சொல்லி கொடுத்தாங்களா?
Yeah.
Okay. What about Ponwani?
Computer background.
Yeah. Did you have a chance to?
I don't remember much.
Okay. That's all right. I'm just
I don't remember, but some things like the terms and all I remember, but I don't remember.
I don't know how to apply. That's all right. I mean, it happens. Okay. So don't get frustrated. It happened to me also. You know, we have to go through that. Remind. That's what is meant by you become. அப்போ நீங்க கேட்பீங்க என்ன சார் லைஃப்ல என்னென்னமோலாம் இருக்கு why do I want to become this ன்னு கேட்கலாம். That's a fair question. I have so many other things to worry about. Why do I have to worry about this also? One more thing, right? So, is it a fair question? It looks like fair question. But all the other things will fade away. As you grow older and older, all the other things will fade away. The creative mind, the mind is always looking for creative activity. That will not fade away until you live. So you have to choose some area of interest to you, which you can apply in your life and show that, you can solve good problems in life. And why not, you have now invested your time, you have invested your money. I invest my time with you. So why not we make this as our creative work? It is a creative work. Any work is creative. I mean, sometimes I advise, I kind of talk to you like a, old person. Some philosophies, and I will talk to you, but that's okay. Don't worry about it. Okay. It's important to connect with, it's important that we connect together, each other. It's money is not the reason why we all live. Money illana kashtam, adu othukuren. But money vanduthunaka doesn't mean that you will be satisfied. But ana creative irukka persongala parunga. When you are creative, you are not thinking about money. You are not thinking about anything for that matter. When your mind is creative, it just enjoys that existence. And we all need some creative work as humans. That's our, I don't know, whatever it is. That's how we are. And solving interesting problems is a creative solution. Is a creative process. Programming also is a creative process, right? Any work is that's what I'm telling you. Any work is a creative process. But you have to make it interesting. That means you have to apply yourself in the creative process. Creative. The mind, the speech, writing, action, the thought, everything have to come together in one thing. That is what the good creative process is. Okay, and that just a side dish. Okay, we just more out of that. There's more of that. So the point is now the minimum and maximum are derivable, can be obtained using first derivative and second derivative. At least as a rule நீங்க எடுத்துங்க. அது ஏன் சொல்றாங்க, எப்படி அது எந்த ஊர்ல இதெல்லாம் கண்டுபிடிச்சாங்க, திங்க் பண்ணி கண்டுபிடிச்சாலும் இப்போ வேண்டாம். We can talk about it, but right now you take it as a rule because we got to move on, right? First derivative and second derivative helps us to get minimum and maximum of a function. Okay, everybody buys that, everybody notes that.
மாட்டீங்க அவரோட
Okay, I closed. I'm sorry. There are too many things in my table, I guess. That's distracting you. Okay. So this way you are missing this one, I guess. So if you take the function, I want to go back to the function I showed you, two different functions, right? I'm going to go back to that. Right now it is filling up the screen, so it is taking time. Okay, just hang in there, it will come through. It's coming. Okay, the whole screen is filled up with that slide, right?
Yes.
Okay. I don't know whether it's good or bad, but what I'm saying, can you? I told something about this function or this function, right? But no, for this actually I started with this one. Are you with me? Okay, what is the function I said here? This is y plus 4 is equal to x minus 3 square. Everybody, can you? Please note down that one. Okay, and you can simplify this also in a different way. Okay, but for now I just want to leave it as it is. Y plus 4 is equal to x minus 3 square. Are you with me, everybody?
Yes, sir.
Okay. Now, if you take the derivative of this, I'm going to tell you the following, and how you are going to convince yourself is not clear to me, because you have to recall your way of calculating first derivative and second derivative, and everybody knows it, but you forgot. But you just have to recall. Okay, so I told you y plus 4 is equal to the first graph. Y plus 4 is equal to x minus 3 square. So you can write it like this: x minus 3 square minus 4 to x square minus 6x plus 9 minus 4, which is equal to x square minus 6x plus 5. This equation, you can also write it. I'm sorry, was there a question? Was it a question?
No, sir.
Okay. So this can be written also as follows. Something has happened. Okay. This is same as writing. This is same as. I'm not going to prove it to you, but I want you to try to understand why I did that way. Okay? Because there are different ways to write. Y plus 4 equal to x square x square minus x square minus 6x plus 9. This is same as, சொல்லுங்க பார்க்கலாம், y is equal to
X square
x square
minus 6x
minus 6x
plus 5.
plus 5. Exactly. Okay. So
First,
let me, 1 second. Let me write this easier to read.
This is the value.
yeah, the key is the value.
The graph
Zero
minus
minus
3 இருக்கும்.
3 minus 4 இருக்கு.
அந்த graph போட தெரியல உங்களுக்கு.
3 minus 4 இருக்கு. கீழே 3 minus 4 இருக்கு பாத்தீங்களா? அந்த plotting point, plot point.
Y plus 4 equal to x minus 3 ன்னு சொல்றீங்க.
ஆமா.
That is the graph for the value range. அது ஒரு ஈக்குவேஷனுக்கு போடுறாங்க.
அது இது
Is everybody with me so far? I will leave it to you to prove yourself. But the point is, let's take a derivative of this. Now, first derivative of y with respect to, இந்த மாதிரி எழுதுவோம், to reduce the space, okay, with respect to x is 2x, excellent, minus 6, right? Rama said that. 2x, who said that? 2x.
Vignesh.
Vignesh, okay. Vignesh, excellent. Whoever said that is excellent, okay? You get a star. எனக்கு கொஞ்சம் வேலை கம்மிப்பா, வேற ஒண்ணும் இல்ல. Okay. What is the, I said we have to find the zero of the first derivative. What does this mean? That means 2x minus 6 equal to 0 means x equal to 3. Are you with me? The second derivative
x square minus 6 into பண்ணலாம் சார்.
அந்த square உள்ள போடுறீங்க.
x into இங்க 2x போடுறோம். x square போடுறோம்.
So அதே மாதிரி எல்லாத்துலயும் பண்ணுங்க.
into இங்க வெச்சுனா சொல்யூஷன் 3x 3 into 5 into 3.
So, what is the meaning of this so far? So, at x equal to 3, we either get a maximum of the function or minimum of the function, right? That's what I told you. In both the cases, it will be like that, right? Or the minimum of the function. Is everybody with me? Is everybody with me?
Yes, sir.
Okay, excellent. Now the second derivative will tell us, my claim is that the second derivative will tell me whether at x equal to 3 we get a maximum or minimum. That is the point. But for that I have to get the second derivative. The second derivative is 2. Everybody agrees? Everybody agrees? Which is 2, which is positive, irrespective of what the value of x is. Including, which is positive, at any value of x, but the main point is at x equal to 3. So what does this mean when it is positive? When the second derivative is positive, at the 0 of the first derivative, when the second derivative is positive, at the 0 of the first derivative, the function attains its minimum. Function attains the minimum. See how I determine the minimum and maximum and where it happens. Are you with me? Everybody? Let's do this. Let's do one more example. Y is equal to, in the function போட்டு பார்க்கலாமா? Is everybody is okay? Can I go to another example? ரொம்ப வேகமா போதா ட்ரெயின்? என்ன ரியாஸ்? Are you with me? Okay. You are able to understand what I'm talking, right? Ponwani,
Yes.
you are not talking from outside the country, right?
Why?
I don't see you where you are.
அது ரொம்ப ஒரு காஷியஸா இருக்கு எப்ப பார்த்தாலும் அந்த வீடியோ நம்மள பாக்கும்போது.
அதுக்கு தானே போடுறது வீடியோவே காமிக்கிறது. நான் வீடியோ காமிக்காம இருந்தேன்னாக்கா உங்களுக்கு ஒரு இன்டராக்ஷன் என்கேஜ்மெண்டே வராது.
தண்ணி எடுத்து குடிக்கணும், திடீர்னு தண்ணி வேணும் அப்படியே போயிட்டு ஓடி வந்துரும் வீடியோ இல்லைன்னா அப்படியே உட்கார்ந்து இருக்க வேண்டியதா.
இப்ப இவங்க எல்லாம் உட்கார்ந்துட்டு இருக்காங்கல்ல மத்தவெல்லாம்.
இப்படிலாம் சொல்லக்கூடாது.
Okay. But the point is, no, it is important that we engage in that intense focus, concentration. அது வேணும். அது it's very important. See, நீங்க கிளாஸுக்கு வந்தீங்கன்னா இருக்கும் இல்லையா? This is the one reason, because we spend a lot of time, Ponwani, okay? We are, we want to make that engaging conversation, experience, intense focus. அது குறையும். ஓகே, நான் உங்களை அப்படி நடுவில் நிறுத்தி உங்களை பத்தி பேசுறேன்னு நினைக்க வேண்டாம். பட் ப்ளீஸ் திங்க் அபவுட் இட். இட்ஸ் வெரி இம்பார்ட்டன்ட். இல்லைன்னா உங்களை வர சொல்லிடுவேன் நான் கிளாஸுக்கு. விச் இஸ் பெட்டர், யூ டிசைட்.
சம்டைம்ஸ் எனக்கு வெப்கேம் நெட் ஸ்லோவா இருக்குன்னு சொல்லிட்டு இட் ஆஸ்க் மீ a suggestion to close my webcam.
One of the reasons we have a understanding with the student who wants to attend from outside is that your broadband is good. Otherwise, we don't want to encourage that, because it's not. You won't get the benefit. You think you are getting the benefit, but you are not. Okay, I'll stop there. I think I am bothering her too much. So let's talk about one more example. Are we ready to go to one more example?
Yeah.
So let's do this example. I just looked at this x square minus 2x plus 3. Let's do that. X square minus 2x plus 3. Let's do that. X square. Don't save. I don't know. Okay. என்னப்பாச்சு விழுந்துச்சா அது? Okay, you're having fun time. Okay, that's fine. Let's do one more example. We are going to do, what is the example we want to do? Y is equal to x square, right?
Minus 2x plus 3.
Control Z, I'm sorry. 2. I don't know, I want to make it as superscript. Plus, I don't want superscript.
சொல்லிட்டு தான் போறீங்க. ஆமா.
I don't want.
கண்டிப்பா. நான் சில்சன் தரமாட்டேன்.
எங்க வச்சு? ஓ, font.
தண்ணி குடிக்க.
கரெக்ட்டா தானே இருக்கு இது. ஏன் மேல போகுது இது? I don't want this to be superscript. Come on. Okay, now it should work better. Okay, plus 2x plus 3.
Minus 2x, sir.
Minus 2x plus 3. Okay, so this is the function we want to work it out this time. Can you find out what is the find out whether the minimum is attained, because a quadratic function will always have a minimum or a maximum. There is no in between. Either it has to have a maximum or it has to have a minimum. So can you find out whether it is a minimum, or at what point it is attaining it is called optimum. Instead of, if I want to say minimum or maximum, I can say optimum.
First derivative is 1.
First derivative is 1. Okay. We usually do it like this. We have all symbols, right? First derivative is equal to
1.
No, 2x minus
minus 2x plus
No,
3.
I am saying the value. First derivative value.
equal to, okay, equal to 0 means x equal to 1. Are you with me? Is that what you're saying? Okay. Second derivative is, what is the second derivative value evaluated at x equal to 1 is what? Second derivative value is always, it's always 2, right? A positive number. Huh?
Yes.
A positive number. Okay, yeah. So is that what we are getting? Why is that? There's something is not correct. Wow. X square minus 2x plus 3. Something is not correct. Wait a minute. Something is not. What am I? X square minus 2x plus 3. Y prime is equal to 2x minus 2 equal to 0 means x equal to 1. Correct. At x equal to 1. Second derivative second derivative is what? Second derivative is 2. Second derivative is 2, right? Okay. First derivative is here. Something is not correct. The function the function not correct. How will I know that? Let's plot it. I think I'm going to plot it and figure it out. Okay. Are you with me? Do you see what I'm talking? Do you all understand what I'm talking?
Yeah.
Yes.
So I'm going to plot this function. I'll use this one. There is a function called plot is available, right? Plot y. No, plot. I want to plot. So what is the R command to plot a quadratic function? I think it is called curve. Curve. You can use curve or plot, right? Curve or plot. Okay, fun. But can somebody do that while I'm doing it in my own way? I'm going to do it in my way, okay? Curve command will be used. That's what they are saying. Plotting a quadratic line. Okay, let's see that.
Line axis that.
Yeah, did you do it already?
I got 3 points.
இல்லப்பா நீ finish பண்ணிட்டீங்களா? Plot போட்டுட்டீங்களா? Plot. Have you done the plot work? I want to, no, not the math. I'm talking about the command, R command, because we want to see this quadratic equation. I want to prove it to you what this curve is, right? I want to prove it to you, whether it is a maximum or minimum. And the way to do is to do, simple plot function in R. Because okay, that's not why it's not helping me. I need a quick commands. I didn't expect to go there. I think I have it somewhere here. I made some comments and codes, I think, but I don't. Just in case, this is the kind of information while I'll have to think about it. No, I didn't read the function correctly. Can you see the function? What does this mean?
Minus x square.
I did not see that correctly. Man, that was a problem. என்னப்பா மைனஸ் இருக்குதுப்பா அங்க மைனஸ் இருக்கு நான் போடல மைனஸ் அதான் now it makes sense, everything works out well. See, there was a minus here. I didn't see it properly because it didn't come out. It's not in a high density, it was not coming out because it's not HD quality, right? It's minus x square minus 2x plus 3. Everybody with me?
Okay, minus x. Okay, sir.
Everybody with me?
Okay.
Now, so what is the second derivative value? It is, first derivative is first of all minus 2x. First derivative minus 2x now. Huh? Minus 2x minus 2, which means x is equal to minus 1. Is this what the graph says? Let's go back to the graph and I want to verify that graph. You see, x equal to minus 1 la தான் அது maximum அடையிறது, right? Okay, so I'm not cheating here. I'm following correctly, but I didn't copy correctly. That was the mistake I did. Okay, now the second derivative is, for this the second derivative is minus 2, right? So which is negative, right? So I told you, when the second derivative is negative, the function attains maximum. எங்கப்பா minimum? Minimum வந்துருந்தானே I was worrying why it is showing me wrong, because pictures shows maximum here, but how could it be minimum? தான் இது அங்கெல்லாம் அப்படி இப்படி போய் கடைசில I found out that oh, I missed a negative sign. Are you with me? Is everybody with me? என்னப்பா யார் சொன்னது minimum சொன்னது? நீ. Okay, Vignesh, are you with me? What I am talking? There was a mistake I made. The mistake was I did not note down the coefficient of x square. I noted down as +1. That was the mistake. And the whole thing was going logically for me. It didn't make sense. And I said there is something wrong, but I didn't know what it was. But then when I looked very carefully, I thought, oh my goodness, I missed the minus sign. Everybody with me?
Sir, one question. In negative values, the number increases, the value decreases, right?
What is it? As the number increases, as you mean the x value increases?
No, sir. Is minus 2 bigger or minus 1 bigger, sir?
Minus 1 is bigger.
Then minus 2 is minimum only, no?
No. Think very carefully. What is the question we are trying to answer? We are trying to answer at what are the points of the function, because it could have multiple minimum maximum also. Let's not go there now. What are the points? First question is this: what are the points? It could be one or multiple points. What are the points at which maximum or minimum occur? Minimum of the function occurs. Maximum of the function occurs. But at what value x the function attains the maximum or minimum? That is the question we are trying to answer. The minus 2 is the value of the function. But x equal to minus 1 is at that point the value of the function attains maximum. But that maximum value of the function is minus 2. Ella value adu kizha dhaan and the function. That's what we are saying. You are getting confused between minus 1, minus 2. Minus 1 வந்து bigger value than minus 2. அதெல்லாம் correct தான். But we are talking in relation to the function. What is the behavior of the function? When we say the maximum value of the function is minus 2, what does that mean? நீங்க எந்த x value போட்டாலும் அதை calculate பண்ணாக்கா அந்த value less than minus 2 தான் இருக்கும். That is what minus 2 means, maximum value of the function. Yes? யாருக்காவது அவர் கேட்ட question ஒரு interesting question. Anybody understands me or not? Nobody understands me? Maybe அவருக்கே புரிஞ்சாலும் புரிஞ்சிட்டு இருக்கோம். விஜி சொல்லுங்க, உங்களுக்கு புரியலையா?
புரிஞ்ச வரைக்கும் சொல்றேன். சோ அவர் வந்து x value -1 -2ன்றது வந்து நீங்க மினிமம் மேக்ஸிமம் சொல்றீங்க. x
value -2 கே போல நான் சொன்ன -2 வந்து value of the function, but -1 ன்றது value of the variable x value. Are you with me? When you say -2, it is really the y value we are talking. Y value, not x value. When we say -1, we are talking about x value. That is the independent variable value. Yes? என்ன விக்னேஷ் புரிஞ்சிட்டு? அப்ப மத்தவங்களுக்கு எல்லாரும் புரியணும், ஏன்னா நீங்க எல்லாம் கேள்வி கேட்கல. எஸ் ஆர் நோ இப்ப சொல்லுங்க. அவர் கேட்டவருக்கு புரிஞ்சு போச்சு. எல்லாரும் அப்படியே பார்த்துட்டு இருக்கீங்க என்ன. சொல்லுங்க. என்னப்பா சதீஷ்?
I got it, sir. I will explain.
அது யார் சொன்னது? ராமா. நீங்க? Okay, sorry, sometimes I get confused with the tone. I know, I think it will take some time. It took 3 weeks to know your name. For tone recognition, it will take. But I think you understood. Okay, good. But what about others? I want to talk to them. அவங்கெல்லாம் சும்மா ஜாலியா ஒன்னும் கேள்வியும் கேட்கல ஒண்ணும் இல்ல அப்படி உட்கார்ந்துட்டு இருந்தாங்க. And when I say when I explained, சொல்லுங்க. Can I assume that everybody understood? Everybody understood? என்ன ரியாஸ் பொன்வாணி முகத்தையே காமிக்க மாட்டாங்க. அவங்க இப்ப தண்ணி குடிக்க போனாங்களா எங்க போனாங்கன்னு தெரியாது. சாரி பொன்வாணி, கலடா பண்ணல. நீங்க இங்க இருந்தா நல்லா இருக்கும்.
இருக்கேன்.
சரி, ஓகே. Sorry sir, சொல்லுங்க. I guess nobody has the question. What he asked, but his confusion was, he was confusing -2 with the x value, but it is really -2 is the y value. It attained the y value at x equal to -1, and it attained the maximum y value at x equal to -1, right, Vignesh?
Now we are considering only about the x value.
Anybody else? Everybody understands? Can I assume that? That's a bad thing to do, assumption. You got to explain. You have to express. Enna Nagaraj?
Correct.
I don't know. I'm creating trouble myself or to you. Then Ram?
Sir, you just explain the graph, sir, so that they can understand.
Yeah. See, at x equal to -1, this is -1. At x, this is x-axis, this is y-axis. Function means what? Y is a function of x. That's what this curve is. Y is a function of x. The y values. For a given x value, for every given x value, you get a y value. That's what a function means. At x equal to -1, it has the y value has the maximum. That's what y is same as the function. So the function maximum. It is same as saying y has the maximum at x equal to -1. Everybody understands now?
Okay.
இப்போ இதே போல இன்னொரு எக்ஸாம்பிள் கொடுத்தா நான் கண்டுபிடிப்பீங்களா?
Derive the values of y value or x value also.
Which one?
Again, derivation back to 1 சொல்றீங்க. அது வந்து x ஓட வேல்யூவா y ஓட வேல்யூவா?
Can you repeat? எனக்கு சரியா கேட்கல, சாரி. சரியா கேட்கல. Repeat.
Derivation value சொல்றீங்களா? 0 1 சொல்லிட்டா அது வந்து x ஓட வேல்யூவா இல்ல y ஓட வேல்யூவா?
Okay. First derivative equal to 0 னா first derivative என்ன 2x என்ன வந்தது அது? First derivative equal to -2x -2 equal to 0. So we are solving for this. We are solving for this தான். Y prime equal to, அதாவது first derivative equal to 0, which is same as this. Right? We are only talking about the first derivative is attaining its maximum or minimum. At this time, we don't know whether it is maximum or not, minimum or not. We don't know. Okay. We are saying it is attaining its optimum value. That is what maximum or minimum. In one word, you can say the same thing. It is attaining its optimum value at x equal to -1. But we don't know whether that optimum is maximum or minimum. அதுக்கு second derivative எடுக்கணும். Second derivative எடுத்தா -2. But it is always negative, irrespective of whatever the x value is. So including at x equal to -1. So it attains its maximum. That is the logic. Okay. எனக்கு ஆன்சர் யார் கொடுத்தது? ஃபர்ஸ்ட் டெரிவேட்டிவ் யார் கொடுத்தது எனக்கு? அவர்தான். எல்லாத்தையுமே அவர்தான். இப்போ நான் ஒரு எக்ஸாம்பிள் கொடுத்தேன்னா அப்போ எல்லாரும் போட முடியுமா? முடியாதா? Try பண்ணலாமா? Okay, let's try one more thing. Okay. With that we will stop.
சரி, இப்போ வந்து x ஸ்கொயர்
cube வந்து
3x வரும்.
இந்த cube இங்க கொண்டு வரணும்.
உள்ள கொண்டுட்டு வந்துடுறாங்க. x minus 3 square law
இப்போ 3x இருக்கு. அத டெரிவேட்டிவ் x போடுவோம். 3 போடுவோம்.
Okay, here is the function y is equal to
-2 அப்படின்னு வந்து
y is equal to x square plus 8x.
சார் one second சார்.
Okay,
x square
y is equal to x square plus 8x plus 15.
plus 15 சார்.
ஆமா ஆமா
what was sir? y equal to x square
plus 8x
8x
plus 15.
plus 15.
Yes, find out whether it is a minimum or a maximum, and at what point the minimum or maximum is attained, and what is the minimum or maximum value. At what time, at what value of x the minimum or maximum is attained, and what is its minimum or maximum value.
Plus 8x plus 15.
முடிச்சாச்சா?
Yes sir.
ஓகே, இருங்க. கணேஷ், நீங்க ஆன்சர் கொடுக்க கூடாது, क्वेश्चन தான் கேட்கலாம். மத்தவங்க போடணும். சொல்லுங்க.
கான்ஸ்டன்ட் கேட்
வேரியபிள் எதுல இருக்கோ அந்த
ஃபர்ஸ்ட் இயர் நான் போட்டுறேன். why this why the second year is 2 அவ்வளவுதான்.
ஆமா வேரியபிள் எதுல இருக்கோ அந்த தான் வேரியபிள்.
then equal to 0 weight தான வரும். Okay.
-4.
Sir, -4 sir.
So first you have to tell me whether it is a minimum or maximum, and then you have to say what is the minimum or maximum value is. What is the x value for which minimum or maximum is attained, and what is the minimum and maximum value? Understand the question?
-4
ஒயினுடைய வேல்யூ ஒயினுடைய வேல்யூ எக்ஸ் ஓட வேல்யூ 0 -2, 0
எங்க போறது 2 வயர் எங்க போறது
ஒயினோட வேல்யூ எங்கேயுமே சப்ஸ்டிட்யூட் பண்ணக்கூடாது. எல்லாத்தையும் சப்ஸ்டிட்யூட் பண்றப்போ
வேல்யூ வந்து ஒயோட வேல்யூவா இருக்கும்.
ஒயினுடைய வேல்யூவா இருக்கு.
ஆச்சா, முடிஞ்சதா?
minus 8 plus இதுதான் நாம வர சொன்னேன்.
நீங்க சொல்லுவா செய்யலாம் அதுல இருக்கீங்க
Priyas, how is it going? You got the answer? Okay. Okay.
அடுத்த டெரிவேட்டிவ் x எடுத்துக்கணும். சோ கான்ஸ்டன்ட் எழுத பண்றது 0. செகண்ட் டெரிவேட்டிவ் x செட்ல இருக்கு. அவ்வளவுதான். 2 தான்.
So this okay is equal to 2 dot.
minus 2.
Okay.
எப்ப y தான் இருக்கு. இப்போ y தான் இருக்கு.
Okay. Sir,
டெரைவ் பண்றது x பொறுத்து based on x
x equal minus 4 and y equal to 2.
Y is equal to 2. Y is equal to 2. At x equal to minus 4, y value is 2.
No.
Yes, sir.
அங்க பின்னாடி குரு உட்கார்ந்துட்டு இருக்காரு. அவரு தலையாட்டுறாரு வேற விதமா. என்னன்னு கேளுங்க அவரை. You got it, Riyas? The answer?
We are going and one is positive or greater than 0.
One is what is the question? Say that again.
When you plot in the coefficient of first.
Coefficient of x square is positive. So it has to be minimum. The y value has to attain a minimum. That is fine. But the question is at what value it attains the minimum and what is the minimum value? That's the question we are talking, right? In this case.
So maximum second derivative sir. And that minimum value is
maximum value
is 0.
The graph I think you still don't get what is meant by at some value the function attains minimum or maximum. Some value of x, the function attains minimum or maximum. That's what we are trying to know. What is the value at which the function attains minimum or maximum, and what is the minimum or maximum value? Do you understand that sentence? There are two parts to the sentence. One is given a function, what is the value that is at which the function attains minimum or maximum? That is first part. Second part is what is its minimum and maximum value? அப்போ அந்த வேல்யூ கண்டுபிடிச்சிட்டு அதை நீங்க சப்ஸ்டிடியூட் பண்ணணும் yல.
yல சப்ஸ்டிடியூட் பண்ணா லைனியர்ல வேற சொல்றோம்.
How much you get?
2 தான் maximum.
You get 2.
2 வந்து maximum சார். 2 வந்தா 2 தான் பீக் அதிகம். y யோட வேல்யூ
இங்க பாருங்க y வேல்யூ என்ன சொல்றது பாருங்க இங்க. I think I am getting -1. That is the minimum value, not maximum first of all. And for x equal to -4, that it attains the minimum and the minimum value. I'm sorry.
X coordinate is -4. Okay.
Wait a minute. What is the function I gave you? Let me solve it for you. Okay. What is the function I gave you? What?
-51.
X square minus 8.
plus 8x
Plus 8. 8x.
15.
Plus 8x. Plus 15. Okay. Maybe this is not the curve. Let's solve this one. First derivative is equal to 2x plus 8, which means x is equal to -4. We all agree on that? X equal to -4. Okay, good. Okay. Now I know because I changed the function. This is not the function. I looked at this one, but I did something else. Y double prime. Second derivative is 2x.
Y equal to
2. While the second derivative is 2, right? So it is attaining the It is attaining the, because whenever the second derivative is positive, it is attaining the maximum. Right? When it is positive, it is attaining the minimum. I don't know why because see, that's why I was looking for a negative coefficient here, and I found out finally, yeah, there is a negative coefficient. But because it is a positive coefficient for the x square, it has to be the minimum. You all agree with me or not? I think Riaz got that one. You asked that question also. You remember, Riaz? Because it's the square coefficient is positive, so it has to be a minimum. You agreed? Everybody agrees with me? I think that's what you were saying, right? You were saying the answer, Vijay. You were saying that answer, right? You were saying that. Well, I know Vignesh was saying that also. What about Nanda Kishore?
Yeah, something, some understanding is going on for me.
Sir, I will explain this in a simple line, sir.
Okay.
We are finding for what value of x, y is giving the maximum value.
Or minimum. It could be minimum also. Yeah, right. Right, exactly. That's what we are trying to find out with this method. Nagaraj, are you with me? Satish?
For what x,
Ram?
y is giving minimum value.
Everybody with me?
Yes.
Okay. Ponwani?
So for x equals 0, on the minus
So end value to y very value chinna value
x on the 0 minus 1
x to 0
Are you with me?
x minus 4
Riyaz?
Yeah, sir.
Okay, it's very fundamental. This is a very, very powerful, useful method, more than your statistical methods that we are going to talk. But it's a general principle that we want to recall so that we can solve some problems. Okay, what is the problem? We can use the same method to solve our linear equations. How to find the linear equation? That's our problem, right?
Okay.
Ram, Riyaz, cool. Okay. Now இவ்வளோ நேரம் இது வந்து this is useful. அதனால ஒன்றும் இல்லை. 1 hour we spend time அதனால it's not an issue because it's very powerful, but we only scratch the surface. Okay, we only scratch the surface because the function can be a very complex function. Let's not worry about that. Interestingly, our linear model is a very simple function. What is that simple one? It's a square function. Whatever we did was a square function. Are you with me? Everybody agrees that it's a square function, right? Like that, the linear model, the error function is also square function, isn't it? We intentionally, we wanted to work only with the squared error function, right? If you remember, what is the slide number? The slide number is estimating regression is 89, that's what we want, 89. But I'm talking about the error sum of squares somewhere I did, which is
number 81.
yeah, I'm going there. Here it is. See, this is the error sum of squares, right? We talked about, the error sum of squares is coming from here, coming from here. Let's see whether I have it there. That I have it somewhere. Error sum of squares. Okay, it's not here. It's not here. I calculated that in some place. Okay, it's here, I guess. Okay. So you remember this? Do you remember this slide sometime back I shared with you?
Yes, sir.
Yes, sir.
And I was saying mathematically we are trying to find that A and B for which this error sum of square is minimum, right? Which is a square function. So it's similar to what we did.
Okay.
Okay? Everybody with me?
Yes, sir.
Okay. Now I'm making a jump now. Now we are going to find A and B. That is our purpose, right? So we can use calculus to find A and B. That is what I'm trying to convince you. So let's go to that.
Now, what it is to find the minimum value of A and B, sir?
No. Minimum value of the errors. We are trying to find out the value of A and B for which the errors are attained at a minimum value. Because we want to minimize the error in our in our best algorithm, our idea of finding best algorithm is that the errors, predictive errors are less.
So that if the line of best fit, the best fit line also will change, right?
No, we will get the best fit. That is the idea. The best fit definition is wherever this error is minimized. That is the definition. That is the definition of best fit.
Yes.
Okay. Any other question? Because from here we quickly jump into the equation that we want to solve, and that solves our problem. Okay, that is this equation.
P value வந்து எதை பேஸ் பண்ணி கண்டுபிடிக்கிறேன் சார்? ஹைபோதீசிஸ் பேஸ் பண்ணி தான் கண்டுபிடிக்கிறோம்.
Yes.
டைப் 1 எரர், டைப் 2 எரர் பேஸ் பண்ணி தான் P value வந்து பாசிட்டிவ் நெகட்டிவ்னு சொல்றது தான் நம்ம பண்றோம்.
Yes. That is about concluding whether it is the variable is valuable, important, significant variable. These are different ways of saying the same meaning: significant, valuable, important variable. That is to determine that. But what I'm trying to say is, I will come to that. Where is the p-value? I'm going to connect it, but let me finish this part. You see, this is called the first derivative. I'm taking the first derivative of the errors here. Okay? Are everybody looking at this? Everybody is looking at this? The screen? Nandakishore is looking at it. Vignesh, Ram, Satish, Vijay, Nagraj, and Riyaz Panwani. Everybody is looking at my screen, right? Where I'm talking about this equation. I am going to leave it to you to convince why this equation is the right thing. I mean, why this equation we are doing, I convinced so far. But அதை பண்ணா இந்த மாதிரி தான் வரும். அதுல இருந்து இதை எடுத்துட்டு வரேன். First derivative equal to 0 பாத்தீங்களா? This is the first derivative. First derivative equal to 0. அதை போட்டோம்னா இந்த மாதிரி equations வருது. இதை நம்ம solve பண்ணோம்னா we get an answer. For A and B, in this case it is B0, B1. It is same. In this case I am talking about it beta naught, beta 1, which is same as B0, B1. So my question to you is that you should not be fabled, oh, where is this coming from? This one. Okay? Where is this coming from? That question should not be there now, given that we talked about it so long, about so much on first derivative, importance of second derivative, all those things. Are you with me? This is an equation in two unknowns. What are the unknowns here?
A and B.
Huh?
A and B.
A not, B not. Or in this case, beta not, B1, B1, B0, B1. Those are the only unknowns. Not N. N we know. How many samples? Given the sample only we are trying to do, right? To fit the model. Right? Nandakishore. Correct? We know the sample. We are trying to solve the best fit. Which means the unknowns are A0, B0 or B0, B1, different ways people call it. So let's not worry about that. The two unknown parameters. Cool. Anybody else? So it is simply a simple two equations, two unknown, because this is known, this is known, this is known, this is known, this is known. So what we are trying to do is, let's go back to that, the 5 observations I put, as an example, right? You recall that 5 observation example? Can we do that hand calculation there and see? You will see whatever your algorithm that is giving by this first derivative, second derivative condition turns out to be same as the OR solution. OR spits out some answer for you, right? And it is the same. So I have the data here. This is Y, this is X. Can we calculate all the things what we want? What are the things we want? Summation of Yi. Can we calculate summation of Yi for this? You remember, this is what I'm going to go bring that equation here, okay? It is 89. This is 28. Let's go to the 89. 89, 89. 89, 89. No, this one. Okay. Let me do this. I'll crop it from here. and then we will solve them, because I want to keep this there all the time to refer. Is everybody with me? This is what I'm going to keep it there near me on the other one, 28 in 28. So my question is, this is the data points, right? -2, -4, 4, -2, 2, 2, 6, 4, 8. Everybody with me?
Yeah.
Given the data point, the question I have is this. Can I calculate summation of yi, which means basically sum of these things? Are you with me? This is done, right? You have to say yes or no. This is done.
Yes.
Okay, thank you. Let's keep doing it. Okay. What about summation of xi? That means this is just the sum of these things. In fact, I can do the mental calculation, which is 10. The summation of this is 8, 6, 14, 18. This is summation of yi is 18. Are you with me? Summation of x is 10.
This 20.
Enapa?
This 20. This 20.
20 minus 20.
இது minus 2 இருக்குப்பா இங்க 14 18 20 minus 2 18. So this is summation of yi is 18. Everybody with me? Summation of xi is 10. Everybody with me? கையாட்டுறீங்களா? I have to come back to this screen. Is everybody with me so far? ரெண்டு கண்டுபிடிச்சாச்சு. Right? Oh, freeze ஆயிடுச்சு உங்க side. Okay. So what I am saying is, let me write it now. And then what about summation? Let's do this little bit of calculation. Now I can put it in Excel and calculate that. But here it is. Summation of yi is equal to 18. Summation of xi is 10. Summation of xi yi, how much is that? அது வந்து plus 8 plus minus 8 plus 8 minus 8 plus 4 plus 24 plus 80. Plus 8 minus 8 பெருத்து 28, 108. Everybody agrees with me? xi yi is 108, and then xi square எவ்வளவு வருது? Summation of xi square is equal to 16 plus 4 plus 4 plus 16 plus 100. 32, 8, 40, 140. So this equation I am going to write it as follows. Watch me very carefully. This equation. Everybody with me? Oh, I lost them. Okay, only we two. Riaz.
Yeah.
Let them come. They'll come. Okay, so I'm going to finish. While they are coming back, I'm going to write these things. 18 is equal to 5 times b naught, right? 5 times b naught plus summation of b1, summation of xi, which is 18 b1. That is one equation. The next equation is summation of xi yi, which is equal to 108 equal to b naught, summation of xi, that is 18 b naught, right? Plus
the summation of b1.
140 b1, 140 b1. Everybody gets these two equations into one now. So this is two equations turned on. Everybody agrees? Let me know.
No, still they are.
One night. This is okay. I need to repeat this. Oops. Oh no. Control Z. Everybody with me? Either
I'm
end.
only
The one division.
18 equal to 5b0 plus xi வந்துட்டு நம்ம 10 கண்டுபிடிச்சோம்ல 18 மறுபடியும் போட்டு
ஆமா ஒரு நிமிஷம். Riaz, did you get it?
No, no, still going on, sir.
Pardon. Okay, what is the question you have, Panwani? One moment, I want to open this.
P1 into 10 வருமா இல்ல 18 வருமான்னு கேக்குறேன்.
18.
Yeah, summation of xi எவ்வளவு வந்தது? 10 தான் correct.
10.
Yeah, you're right. Yes. Right. It should be 10. அப்போ இங்கேயும் 10 தான் வரும் இல்லையா? This is 10. ஒரே ஒரு y summation of yi தான் வருது. Only once. 2 times summation of xi வருது. And then here, okay.
Net work ஆகல சார்.
No problem. நீங்க அங்க கனெக்ட் பண்ற நேரத்துல நாங்க இதெல்லாம் ஒர்க் பண்ணினோம். So what I'm saying is, do you see these equations? These equations, when I rewrite it, it comes out to be like this. Just I want you to coolly think. Parameters are these. These are parameters. Unknowns. This is two equations in two unknowns.
Sir, please can you repeat it once again, sir?
One minute. So what I said is, this is the data, right? This is y value, this is x value.
Okay.
Summation of y values கூட்டினா வரும். That is what this left hand side is. That is 18. Summation, the number we said, this is 18, right? Summation of y value. Summation of xi values, x value is 10. So in the part 10, that's why you get 10b1. In the part 18, that's why you get 18 equal to 5, n is equal to 5. So 18 is equal to 5 times b0 plus 10 times b1. 10 times b1. This is done.
So 5 is b0 முன்னாடி.
N is number of sample. N is number of sample. N is number of sample, right? Yeah.
And 10 b0 is 10 is
10 is summation of xi. இங்க பாருங்க. Summation of xi.
okay.
18 is summation of yi.
Oh, yeah, got it, sir, got it.
108 is summation of cross product of x and y. அது சம்ம பண்றோம். அதுதான் 108. Okay?
Okay.
Final unknown is the only thing, summation of xi square. இதெல்லாம் ஸ்கொயர் பண்ணி ஆட் பண்ணுங்க. That is 140.
Okay.
16 plus 16, 32 plus 4 plus 4, 8, 40, 100, 140. அதான். So my point is this, not a question, my point is, this is two equations in two unknowns. Can we solve for b0 and b1? Yes. And if you solve, let's solve that one. Can we solve? How do we solve?
First multiplying by 2. First we
Do
have
that.
2.
There are many ways to do that. I think you can do, maybe, or you can use to solve. Okay, solving equations in R. I'm going to use R. Okay. Let's see. Solving linear equations. Solve equations. Solve simple equations. Systems equations are better. Solve A, comma B. A is your matrix and B is your right side. In this case, it is left side. So, for example, try solve A. A, comma B. That's correct. I will see example. Okay. Okay, here is this. So A is busy. Yeah, that's what I said. Okay, but 3 is coming as what? What is 3 here? 3 equations and 3 unknowns. Okay. but we have only 2. The end rows is 2. Okay, rounding value. Okay, all right, let's do this one. I'm going to copy and paste this and run this again. That's what I'm going to do. Ennoda values along the C is end row is 2. 2 equations. So now we have 4 values here. C value is only 2. End row is 2. By false. Okay, so the values of this is 5, 10, 10, 140. 5, 10, 10, 140. This one is 18, 18, 108, 18, yeah, 18, 108. This 2. Round the this one. Let's try this. It should solve. Something has happened. Solve maybe error in solve default API. 2 by 3 must be square. Oh, what happened 2 by 3? Why it came 2 by 3?
இது வந்து வேரியபிள் வந்து சுமால் வாங்கியிருக்கோம். சுமால் ஏ வேரியபிள் சுமால் ஏ சுமால் பி வாங்கியிருக்கோம். மேட்ரிக்ஸ் இப்போ நம்ம சால்வ்ல வந்து கேபிட்டல் ஏ கொடுத்துருக்கோமே.
இல்ல இதுக்கு அதுக்கு அங்கே இருந்து நான் டிரைவ் பண்ணி இங்க போடுறேன். It doesn't matter how I represent on R. So that's okay, right? It's nothing to do with அதே போல தான் இருக்கணும் அவசியம் இல்லை. But I just trying to give you some codes because usually in mathematics we say this, right? AX equal to B. That's a set of equations, right? That's how they people are structuring. You can do, but the point is this is the coefficients of X. We haven't solved the problem yet. It's a matrix. Data is equal to this. Okay, so let me see whether it's all noted correctly. A is that's the problem. Okay, A is not corrected. N column should be not 3, it should be 2. That was the problem here. Okay, now it should work out. You see what is the answer? The B0 is 2.4. Are you with me? This is what the answer is. And what was the LM model? You remember that one? That is here already. I will show you. So the LM model solved the problem here as follows. What is that? It's coming here, somewhere here. இது வந்து visual பண்ணது. Coefficient of X to be 1 and then intercept is 2. That is a visual answer, but the actual answer is I calculate that using LM modeling, right? You remember that? One second, I have to go to that page. LM modeling. Not this one. No, not this one. This is the one. You remember this slide? I actually built the model using LM package. Are you with me? What is the intercept? 2.4. Coefficient is 0.6. And that's what we got here also. But I was coming from the solutions of equations. I was coming from the solutions of equations. You see how I am going through the logic? Everybody?
Yeah.
Nandakishore is cool, Vignesh is cool, Nagaraj is cool, Ram is cool, Satish is cool. What is not cool? So what is not? You see, I went through few steps here, but what was the purpose I was trying to do? We did before, not in this class, we did before LM package use panni, adhe problem solve panna. We got the answer 2.4 and 0.6. We got that, but that is a package. We don't know how it came through, right? And I'm showing you how it did the problem. This is how they are using the solutions of equation method to solve the problem. Riaz, are you with me?
Yes, sir.
One morning.
Yes, yes.
Okay. So everybody is cool. Vijay, you are hesitating. Cool. Now, what did we achieve? I convinced you there is a definition of what is meant by a best fit for a given data. Best fit. I also convinced you that using the LM package you can do the modeling. And I also explained various parts of the model outputs, p-value, t-value, coefficient, coefficient is same as slope and so on. Different words I used, confused you sometime, and then you all came out of it. I did all those things. Explanation of the output using the LM package function, okay, function LM to get the best fit. I showed you how the algorithm actually solved behind the screen using systems of equations. That's what I proved it to you. So you can convert that for however many number of variables you have, you can write it that many number of equations if you are going to do the minimum least squares. This is the minimum least squares. This is the least squares of the errors, right? The least squares of the errors, that's what we are doing. The minimum least squares. We minimize the errors. And that gives rise to systems of equations that is solved behind the screen. This is how you get it. I think one question is still pending. Ram, I think I asked, இங்கேருந்து எப்படி நம்ம p-value கிடைக்குது அப்படின்னு கேட்டார். Very important. எங்கேயோ போயிடுது இல்ல, beta not b0 b1 கண்டுபிடிச்சு கொடுத்துட்டேன் நான். எங்கேருந்து p-value? That's the question. So what p-value says is that in the beta not b2 b1 b0 b1 there is no one value. It just so happened it is coming out of the sample, given a sample, but next time when you go back to the population to take a sample, who knows, you may get a different b0 b1. But if the process is systematic, your sample is random, again and again you take it, it is not going to be exactly the same value, but it's going to be some distribution around it. Different possible values, but mostly centered on the mean of that b0 and b1 value. Everybody with me so far? And the distribution coordinate value பார்க்கிறது p value பார்க்கிறது தான் அந்த p valueன்றது. And is that distribution இப்போ ஒரு பீட்டா ஒரு b0 நம்ம கண்டுபிடிச்சோம். Next time வந்துனா it may be 2.01 or it may be minus 1.98. Okay, but most of the value should be around 2. And that 2, is it significantly different from 0 or not? That is what the p-value is telling you. That 2, which is the mean of that, in other words, you keep on taking the sample, repeat that one, you are going to get different beta naught, but its mean value will be 2. There is a theorem behind it, why it is 2. When I say that the mean value will be 2, now I know it, because I read that theorem, I know it. Okay, so there is a probability distribution around beta naught, b0, there is a probability distribution around b1. Is that probability distribution significantly different from 0 or not? That is the question every time we address when we look at the p-values. Each of the coefficient is different from the 0 or not. Yes? Everybody is cool? மறந்துரும் ஆனா இது எப்படி ஞாபகம் வச்சுக்கிறது நான் சொன்னது கொஸ்டின்ல எக்ஸாம்ல கேட்டா வந்துரும் ஞாபகம் வந்துரும் ரைட் எக்ஸாம் கொஸ்டின் அது கொஸ்டின் பேப்பர் லீக் ஆயிடுச்சு எக்ஸாம் கொஸ்டின் கட்டாயம் கேட்பேன் நல்ல கேள்வி அது இட்ஸ் a beautiful question and there is a beautiful answer behind it. There is a process going on behind all these things, logical process.
டிவிஎல் கண்டுபிடிக்கிறப்ப முன்னாடி ஹைபோதீசிஸ்ல ஆல்பா ஃபர்ஸ்ட் பார்ப்போம் ஆல்பா கிரேட்டர் தானா பீட்டா கிரேட்டர் தானான்னு பார்க்கலாம் ஆக்சுவலா டிவிஎல் ஆல்பா பீட்டா ரெண்டையுமே கண்டுபிடிச்சா டிவிஎல் கண்டுபிடிப்போம்
Alpha P is in this case we are only talking about alpha, related to alpha.
Related to alpha only.
We are only relating it to alpha only. Okay, everybody is cool. Who is not cool? And being not cool is good. Remember that it's not bad. It's okay. It's all right. Everybody understands what I said? Riyas, Punwani.
Yes.
Is that clear when I say that there is a probability distribution around B0 and B1? Separate probability distribution around B1 also? Does that make sense to you? எதனால வருது probability distribution? I explained it, but can you repeat that to me? எதனால வருது? Because we took a sample and that sample doesn't have to be same next time when we take another sample. The whole modeling is happening based on sample values. இப்படின்னா என்ன அர்த்தம்? Are you cool? Okay or not? Thank you. Thank you, Nandakrishna. Vignesh. 2 பேர் தான், 3 பேர். ரியாஸ்.
Yeah, sir.
3 பேர் தான் வந்தது. Yes.
Everyone got tired, sir.
Thanks, Nandakrishna. அவர் எங்க கையில நிறைய கோல்டு போட்டிருக்காரு, அது வெயிட். என்னப்பா?
Platinum.
Okay. Something. Okay. But think about these things. There are a lot of interesting things that are happening. Why statisticians, mathematicians say certain things are true. They rack their brains to make sure that all these things are correct. It's all consistently playing out. They all have worked together, these ideas. Okay. So it's already 9:15. Now I want to go to another topic. So, Vignesh.
Before 5 minutes break.
Good point. தண்ணி குடிக்கிற நேரம். Or டீ கூட குடிக்கலாம். பக்கத்துல தான் இருக்க டீ ஸ்டாப். Have fun. But please come back in 10 minutes, okay? I give you extra 5 minutes. Let's finish one more important topic before we go.
Sure.
Thanks.
Sure.
இந்த போன் அடிக்கடா.
பையா
கூப்பிடாம போற. போன் அடிக்காம போ.
ராமசாமி போப்பா.
எங்க இருக்கீங்க? தலையை காமிங்க ஃபர்ஸ்ட் நீங்க. தலையை காமிங்க. தெரியுமா?
Yeah, come to my house, we'll have a cup of coffee.
ஒரு டேட்டா செட் எடுத்துட்டு இன்டர்வல் வச்சு நீங்க வந்து ஸ்டாண்டர்ட் டிவிஷன் கண்டுபிடிப்பீங்களா, டிவியேஷன் கண்டுபிடிப்பீங்களா, எஸ்டி கண்டுபிடிப்பீங்களா? போன்ல வாங்க நீங்க கேக்குறேன். ஒரு டேட்டா செட் கொடுத்துட்டாங்க உங்களுக்கு, 2 டேட்டா செட் இருக்கு. அந்த டேட்டா செட் எடுத்துட்டு இன்டர்வல் கொடுத்துட்டாங்க, ஃப்ரீக்வன்சி கொடுத்துட்டாங்க. இது ரெண்டும் கையில இருக்கு. இதை வச்சு வந்து குமுலேட்டிவ் ஃப்ரீக்வன்சி கண்டுபிடிக்கலாம். சரிங்களா? கண்டுபிடிச்சிட்டு மீன் அண்ட் மீடியம் எல்லாமே கண்டுபிடிச்சிருக்காங்க. நெக்ஸ்ட் அது வந்து எஸ்டி வேல்யூ கண்டுபிடிக்கணும், எஸ்டி எரர் கண்டுபிடிக்கலாம். கண்டுபிடிச்சிருக்கீங்களா? எஸ்டி வேல்யூ எஸ்டி எரர் கண்டுபிடிச்சிருக்கீங்க. கண்டுபிடிச்சப்ப நீங்க வந்து உங்களால ஸ்லோ போட முடியும். ஒரு வேல்யூ வச்சு ஸ்லோ போடுறீங்க. ஸ்லோ போட நமக்கு எந்த இடத்துல வேல்யூ கண்டுபிடிச்சிருக்கோம், ஸ்லோ எடுத்துட்டு இதுதான் பி வேல்யூ சொல்றாங்க. இதான் வந்து பி வேல்யூ சொல்றாங்க. இந்த ஸ்லோப் இப்படி இருக்குன்னா இந்த ஸ்லோப் வந்து இப்படி இருக்கும். நம்ம இந்த இடத்துலதான் வந்து 1.96 சொல்லி எனக்கு சார், இங்க வந்து 1.96. இதுதான் வந்து பி வேல்யூ அப்படின்னு சொல்றாரு. பி வேல்யூ இது இதோட வேல்யூ வந்து ஸ்டாண்டர்ட் டிவிஷனோட வேல்யூ வந்து தெரியும் நம்மளுக்கு. இந்த வேல்யூ வந்து நம்ம வந்து இந்த சார்ட்ல பார்த்துட்டு அதோட பி வேல்யூ என்னன்றதை எடுத்து எழுதிதான் பி வேல்யூ. இந்த வேல்யூல வந்து ஆல்பான்னு ஒன்று இருக்கும், பீட்டான்னு ஒன்று இருக்கும். ஆல்பா வச்சு மட்டும் தான் கண்டுபிடிக்கணும்னு சொல்றாரு சார். ஆக்சுவலா இந்த பி வேல்யூன்றது ஒரு கான்செப்ட் வந்து எதனால வருதுன்னா ஹைபோதீசிஸ் பேஸ் பண்ணி தான் வருது. ஹைபோதீசிஸ் வந்து நெகட்டிவ் பாசிட்டிவ் ரெண்டு இருக்கு. அதோட வேல்யூ வந்து நம்ம கொடுக்குற வேல்யூ வந்து எஸ்டிமேட் வேல்யூ வந்து நம்ம எவ்வளவு எஸ்டிமேட் 95% இருக்கும் அப்படின்னு நம்ம பண்றோம். அதுல வந்து அதை பேஸ் அந்த 95% இங்க வந்து அப்ளை பண்றப்ப இது வந்து ட்ரூவா ஃபால்ஸா அப்படின்றத ஃபைண்ட் அவுட் பண்ணி முன்னாடி தான் நம்ம வந்து ஹைபாதிஸ் வந்து ட்ரூ எல்லாமே வந்து நம்ம வந்து ஹைபாதிஸ் வந்து ஆல்டர்னேட்டிவ் ஹைபாதிஸ் தான் பண்றோம். வேறு ஹைபாதிஸ்லாம் நம்ம எதுவுமே தொடர்றது கிடையாது. ஹைபாதிஸ் ஃபுல்லுமே பேஸ் பண்ணி எதை பேஸ் பண்ணோம்னா ஆல்டர்னேட்டிவ் ஹைபாதிஸ் தான் பேஸ் பண்றோம். இதுல வந்து என்னன்னா நோ இன்க்ரிமெண்ட் நோ வந்து சேஞ்சஸ் எதுவுமே இருக்காது. நல் ஹைபாதிஸ் நல் ஹைபாதிஸ் மீன்ஸ் நல், அதனால எந்த சேஞ்சஸுமே இருக்காது. ஆல்டர்னேட்டிவ் ஹைபாதிஸ்ல தான் எல்லா சேஞ்சஸுமே இருக்கும். நீங்க என்ன வந்து ஒரு குரோவுக்கு வந்து ஒரு மரத்தை வளர்த்தா கூட தண்ணி விட்டா கூட ஆல்டர்னேட்டிவ் ஹைபாதிஸ்ல வளரும். ஏன்னா அந்த ஆல்டர்னேட்டிவ் சேஞ்சஸ் இருக்கு, இதுல எந்த சேஞ்சஸும் கிடையாது. அதனால எல்லாமே ஆல்டர்னேட்டிவ் ஹைபாதிஸ்ல தான் பண்ணிட்டு இருக்கும்.
கொஞ்சம் புரியுது. ஆனா எதுவும் சொல்லுவீங்க, ஆனா இதுக்கு இது சம்மந்தம்
எல்லாமே வந்து டி வேல்யூ வச்சுதான் மட்டும்தான் பேஸ் பண்றோம். அந்த சம்மந்தம் தான் கேட்டுட்டு இருக்கேன். இப்ப நீங்க எதை பேஸ் பண்ணி கிராஃப் போடுவீங்க? ஃபைனலைஸ் எதை பண்ணுவீங்க? டி வேல்யூ தானே ஃபைனலைஸ் பண்ணுவீங்க. இவ்வளவு போடுறது எல்லாமே எங்க போய் இதனுடைய எண்ட் எங்க?
சிக்னிபிகன்ட் லெவல் வந்து 0.05 அதை விட கம்மியா இருந்தா நல்லதுன்னு சொல்லுவாங்க.
சிக்னிபிகன்ட் லெவல் வந்து நம்ம எடுத்துக்கூடிய சிக்னிபிகன்ட் லெவல்ல நீங்க தான் பிரான்ச் மேனேஜர், நீங்க வந்து இன்னைக்கு ஒரு 50 ரூபா கொடுக்கலாம் 50 ரூபா கொடுக்கலாம், அவ்வளவுதான். அது போல கொடுக்க முடியாது. அதான் சிக்னிபிகன்ட் லெவல். சிக்னிபிகன்ட் we can type any ஒரு வேல்யூன்னு வச்சுக்கோங்களேன். இன்னைக்கு எரர் வரக்கூடாது. எரர் வந்து 5% தான் அதுல இருக்கணும். அதான் சிக்னிபிகன்ட் லெவல். அதான்
ஐடியா இல்லை. நீ சொல்ல கொஞ்சம் புரியுது, நான் ஃபுல்லா படிக்கல. சோ எனக்கு கொஞ்சம் புரியுது, கொஞ்சம் புரியாம மாற்றம்.
அதான் வச்சுட்டு இருக்கேன். இப்பதான் நான் கொஞ்சம் பார்க்க ஆரம்பிச்சிருக்கேன், அதனால தெரியும். இப்ப முன்னாடி வந்து ஸ்டாண்டர்டைசேஷன் தெரியாது, ஸ்டாண்டர்ட் தெரியாது. அதெல்லாம் வந்து ஈஸியா கண்டுபிடிச்சல. எல்லாத்துக்குமே ஃபார்முலாஸ் இருக்கு. எல்லாத்துக்குமே ஃபார்முலாஸ் இருக்கு. ஒண்ணும் இல்ல, வேரியன்ஸ் தெரியுமா? வேரியன்ஸ் வந்து சிக்மா வந்து வேரியன்ஸ் சிக்மா ஸ்கொயர், வெறும் சிக்மா வந்து ஸ்டாண்டர்ட் டிவிஷன்.
ஸ்கொயர் ரூட் ஆஃப் சிக்மா வேரியன்ஸ் தான்.
ஆமா, ஸ்கொயர் ரூட் ஆஃப்
வேரியன்ஸ் இஸ் சிக்மா.
இங்க ஸ்கொயர் போட்டு ரூட் போட்டு இங்க போட்டுதானா இது வந்து வேரியேஷன். வேரியேஷன்
ஸ்கொயர் ரூட் ஆஃப் வேரியன்ஸ் தான் ஸ்டாண்டர்ட் டிவிஷன்.
ஆமா, அதுக்குதான் நீங்க ஸ்கொயர் போடுறதுனால இங்க ரூட் போடுறோம். இது வந்து வேரியன்ஸ். இந்த தூக்கிட்டு வந்து இதை போட்டோம்னு வச்சுக்கோங்களேன், இது வந்து சிக்மா, இது வந்து ஸ்டாண்டர்ட் டிவியேஷன். எல்லாமே ரிலேட்டட் பிட்வீன் ரிலேட்டட் வேரியன்ஸ். ஃபர்ஸ்ட் வேரியன்ஸ் தொட்டு ஸ்டாண்டர்ட் டிவியேஷன், ஸ்டாண்டர்ட் தொட்டு ஸ்டாண்டர்ட் வருது. இது வந்து காலைல வந்து ப்ரெடிக்ட் எரர்னா என்ன அப்படின்னு கேட்டாரு. அது தெரிஞ்சுச்சா? ப்ரெடிக்ட் எரர்னா கேட்டாரு, மாடல் எரர்னா கேட்டாரு. அதுதான் நீ ஸ்டார்ட் பண்ணாது. மாடல் வேரியன்ஸ்னா என்ன, டோட்டல் வேரியன்ஸ்னா என்ன, எரர் வேரியன்ஸ் ஃபர்ஸ்ட் சொன்ன முன்னாடி தான் நம்ம அடுத்தது இப்போ ஆஸ்க் என்ன, லீனியர் ரெக்ரேஷன் என்ன, ப்ரெடிக்ட் மாடல்னா என்ன, இதெல்லாம் வந்து எதுவுமே சொல்லலையே.
చెప్పు
ఫస్ట్ 5 minutes 10 minutes మిస్ అని ఏం చెప్పాడు?
అస్సలు ఏం లేదు, కరెక్ట్ గా చూసావా? అప్పుడే స్టార్ట్ చేశాడు.
అప్పుడే వచ్చాను. ఓకే ఓకే.
అలా ముందే ఆమా అది ఏమో జస్ట్ వి స్పీక్ అబౌట్ ద వీక్ డే క్లాసెస్. ఏదో ఒక రోజు పెట్టమని చెప్తారంటే అదే హాఫ్ అన్ అవర్ మాట్లాడాము. నువ్వు వచ్చావు అప్పుడే స్టార్ట్ చేశాడు.
అట్లా ఎప్పుడు పెట్టాడు?
యువర్స్ ఓన్లీ వెయిటింగ్ ఫర్ యు ఓన్లీ.
ఏంటా
ఏమి నువ్వు వచ్చినప్పుడే స్టార్ట్ చేశాడు. దాని ముందు మేము వీక్నెస్ గురించి మాట్లాడాము. క్లాస్ ఒక రోజు పెట్టండి అంటే సజెషన్ తీసుకుంటాను.
ఏమన్నాడు వీక్ డేస్ అంటే?
అదే అందరు అన్ని మాట్లాడుకొని ఫైనల్ చెప్పండి అని చెప్పాడు. కన్సల్ట్ పని అందరినీ ఫైనల్ చెప్పమన్నాడు.
మనకి వీక్ డేస్ మనకి వీక్ డేస్ లో ఎప్పుడు పెట్టినా ఓకే కదా పిఏ?
మనకు ఓకే, కానీ వాళ్ళు ఇద్దరున్నారు కదా, మిగతా ఇద్దరున్నారు కదా, వాళ్ళ గురించి ఆలోచిస్తున్నారు. వాళ్ళు ఓకే అంటే పెట్టారు, వెడ్నెస్డే పెడతాడంట.
ఎవరిద్దరు? నవీన్ అండ్
నాగరాజ్.
ఓకే ఓకే.
పొన్నవాణి
నాగరాజ్,
నవీన్ నాగరాజ్, పొన్నవాణి నవీన్ నాగరాజ్.
எனக்கு ஒன்றும் ப்ராப்ளம் இல்லை. வீக் டே கம்பெனி வீக் டே நம்மளுக்கு பிஏ வச்சாலும் ஓகே. வி ஆர் ஈகர் டு ஹேவ் சப்ஜெக்ட் ஆன் தட்.
మరి మాట్లాడతాము మరి చెప్తారు అందరూ ఉన్నారు
ఎవరు సరే సరే
எதா இருந்தாலும் டீல் பண்ணாதீங்க பப்ளிக்ல பேசாதீங்க ஓபன் ஸ்டேட்மெண்ட் பப்ளிக்ல பேசாதீங்க ஓபன் ஸ்டேட்மெண்ட் இது போன்ல
இந்தியா கம் டவுன் ஷோ சார் நம்ம பேசலாம்
நீங்க போனே பண்ண மாட்டீங்க நீங்க எல்லாம் பேசாதீங்க போங்க போன
இல்ல
கூட
இல்ல ஓகே ஓகே புரியல
இப்ப முடிஞ்சதா இல்லையா
யா
ஓகே
Are you with me? Are you with me?
Yes.
I'm making any sense? No. Surely.
அவரு
என்னப்பா டீ பிரேக்னு சொன்னா நாகராஜ் அங்கிட்டே போயிட்டாரு
எல்லாம் ஒரு ஆள் தாங்க கண்டே மாட்டீங்க பெரிய ஆள் ஆயிட்டீங்க
அல்ல நானா
சொல்லித்தரேன் நீங்க
இல்ல ஜெதன் இல்ல பைத்தான் ஐ வில் ஹெல்ப் யூ த்ரூ பைத்தான் அது டென்ஷன் இல்ல இந்த பிஏ நீங்க தான்
பிஏ வந்து சந்தோஷ் சார் இருக்கிறாரு நீங்க கவலைப்படாதீங்க நந்தகுமார் சார் ஓகே அடிச்சுக்க ஆறு பாத்துக்கங்க
The fine day we are going to catch Mr. Nandakumar for the PA for complete knowledge on this. We need a demonstration from him in the class for a past hour. Is it okay?
PA SAS also SAS.
Yeah, including both SAS and PA. The complete demonstration for.
நடத்துங்க ஆஃபர்லாம் கையில வாங்கி வச்சிருக்கீங்களாமே
பிஏவா
இல்ல பிஏ வந்து ஆஃபர் வாங்கிட்டீங்க போலயே டேட்டா சயின்டிஸ்ட்னு சொல்லி அது தம்புல இருக்கீங்க போலயே அப்படியா
இல்ல லிங்க்லாம் இருக்கும்ல கோர்ஸ் கம்ப்ளீட் போகணும் தான்
இல்ல அதுக்கு முன்னாடி இது கிரிக்கெட் மேட்ச் போக பாத்தீங்களா செலக்ட் ஆனவனே அவங்க என் டீமுக்கு விளையாடலான்ட்டு கிரிக்கெட் மேட்ச் பாத்துட்டீங்களா என் டீமுக்கு விளையாடவா அதே மாதிரி நீங்க படிச்சுட்டு இருக்கப்ப எங்க அமெரிக்கான்னு கூப்பிட்டு இருக்காங்க
actually he planned everything regarding
அதனால நீங்க பக்கம் வர மாட்டீங்க அப்படிதானே
இல்ல அப்படி ஒண்ணும் இல்ல ஜி எனக்கு கொஞ்சம்
அப்படிதான் நான் நினைக்கிறேன் டெய்லி வீட்டுல உட்காந்துருக்காங்களா எனக்கு அதான் என்ன எதுக்காக
இதுதான் போன்ல நான் போன்ல பேசுறேன் அப்ப இந்த கிளாஸ் இது கால் ஜாலியா இருக்கேன் எனக்கு என்ன டென்ஷனு
டென்ஷன் வெளியே காமிக்க கூடாது வெளியே காமிச்சா நல்லா இருக்காது
அப்படியா
டென்ஷன் வெளியே காமிச்சா எதுவுமே பண்ண முடியாது
அந்த ஸ்டேஜ் எல்லாம் தாண்டி வந்துதான் இங்க நிக்கிறோம்
அதனாலதான் வச்சுட்டு இருக்கேன் அந்த ஸ்டேஜ் அதனாலதான் இப்பயே ஆரம்பிச்சிட்டேன் அடுத்த மாசம் ஆரம்பிச்சேன் டென்ஷனை இந்த மாசம் ஆரம்பிச்சது ஹைதராபாத் போலாமா
பெங்களூர் no need of going Hyderabad. Bangalore is a good market for that.
சரி பெங்களூர் எப்போ போறீங்க நான் வரேன் I will come and join with you.
Sure.
Bangalore.
Sure. Sure. There is no worries about that.
Then we will go to Bangalore.
I'm very happy now. என்னோட
நான் எப்போ போறோம் பெங்களூர் போலாம் ஜி எப்போ போலாம்
நீங்க சொல்லுங்க ஜி இப்போ வரலாமா டிக்கெட் போட்டுறவா அப்புறம் டிக்கெட் ரெண்டு
ரெஸ்யூம்ல ரெடி பண்ணிட்டு போலாம் போலாமா
போலாம்
ரெஸ்யூம் ரெடி பண்ணிட்டு அப்படியே கிளம்பிடலாம்.
எனக்கு நந்தகுமாரோட பிஎஸ் என்ன போதும்.
அவருக்கு ஆல்ரெடி உங்களோட அவருக்கு அப்பாயின்மெண்ட் நிறைய இருக்கு.
Yeah, actually I need a great subject on that. Nanda knows, so you have to explain me regarding this.
Wait.
I missed. Where these guys are? Enga you galla 5 minutes tea break la.
This better. Adile.
First half an hour plan போச்சுனா 1 hour எடுக்கும்.
Hey, signal problem ఉంది మీ
நாளைக்கு லீவா இருக்கா?
யாருக்கு?
ஜி இதெல்லாம் காண கொடுமதி. இப்பெல்லாம் பண்ணாதீங்க. சாப்பிட்டு இருக்காரு எங்க நாங்கெல்லாம் பார்க்க வச்சுட்டு அதுக்குதான் வீடியோ சாப்பிடுறேன் பாருங்க எப்படி சாப்பிடுறேன் பாருங்க வெளியே காமிக்கிறாரு.
ஆமா
ஜி இதெல்லாம் டூ மச் ஜி, டூ மச். You are doing too much work.
exactly. phone ஆளல ஒரு மார் வச்சிட்டே. Have you seen my
complaint பண்ணுங்க ஜி.
This is my new house.
Well. When did you change?
There is a Tambaram.
2 days before, huh?
Yeah.
உங்களுக்கு டீ காபி எல்லாம் கொடுக்கறதுக்கு முன்னாடி அடிக்கணும் ஜி. ஒழுங்கா கிளாஸ்க்கே வரதில்ல, உங்களுக்காக கொடுக்குறாங்க பாத்தீங்களா? பட்னி கூட சொல்றோம்.
யாரு பத்திலே நீ ஒண்ணு.
ஆமா ஜி, நானும் ரீசெண்டா கேள்விப்பட்டேன். மில்லியன் அடுத்த பில்லியன் எப்படி ஆகுதுன்னு பாத்துக்கோங்க.
அதுக்கு நீ இருக்கே நந்தகுமார் இந்த டாப்.
ஜி அம்பானி வந்து கஸ்டமர்ஸ் வந்து அவருடைய ஜியோ கஸ்டமர்ஸ் வந்து 57 மில்லியன் இருக்காங்களா, அதை எடுத்து அந்த டேட்டா எடுத்து எப்படி வந்து ப்ரெடிக்ட்ல இன்சர்ட் பண்றான்னு தெரிஞ்சுக்கலாமா? ஜி வந்தாங்க
5 minutes தான்ப்பா பிரேக்.
விக்னேஷ் அதான் அந்த 4 minutes சொல்லாச்சு. நானும் தான் 2 minutes வந்துருக்கேன்.
சமோசா பச்சா சமோசா
இங்க பாருங்க டீமோட டான் நானா ஜெலரன் கேட்டு நானா கோபம் வர போறாங்க. நானா டான்
என்ன டீம் பேஜோட
यस भाई
बोलो.
कहाँ चल रहे?
मैं घर में था यार.
ये अंदर से खाना.
और क्या?
ना बोल.
दिन में कंफ्यूज हो रहा.
या.
सेकंड टाइम यार लेना तो कटर पर नहीं
Sir, your voice is not audible, sir.
और इन पेज में आप बोलने
का
All right. Okay. We'll have another 40-50 minutes maximum. We'll finish
1 hour also okay, no problem.
1 hour.
1 hour also okay.
1 hour is also okay. நீங்க மட்டும் தானே சொல்றீங்க?
Okay.
3, 4, 5. என்னப்பா? என்ன சொன்னீங்க? என்ன ராம்?
Full day sir.
You are creating trouble for everybody. ஒருத்தர்கிட்ட மட்டும் எனக்கு வரலையே மெசேஜ்.
Yes, sir.
Yes, Bhaira.
No,
Are you also ready for more than 1 hour?
I'm ready for yours, sir.
Okay, thank you. All right, cool. Very nice, very nice, very nice. But there is a lot to learn. See, we have to be. It's good that you get interested. It's very important. But there is so much to learn. But foundations have to be very strong. Because once you have the foundation, actually, it is surprisingly, it will become easier for you to learn yourself also. Okay, so let's get the foundations, strongly built. That is the idea. Now, so let's again review what are the things we have covered so far. I showed you Galton height, father's height and children height example, and then I showed you a box plot. You remember that box plot? For various heights of the father, there was a box plot. And then I took the mean points and then tried to show you that they all seem to lie on a line, but not really on a line, but seem to most of the times, right? But the idea is not that we are trying to find a line that fits all the averages, conditional averages, but approximately as a line so that the errors are the minimum. That is the principle. And then we also did the 5 observation example. That small example actually just before the end of last class also I kind of worked out and showed to you. I recalled that LM execution. I showed you that behind the screen in the R, there is really a systems of equation that is going on in terms of how these things are solved. There are different ways to look at this. One is a systems of equation. Another one is matrix approach. I will come to that later. Okay, because that will be almost the end of the situation. Not end. After some of these lessons, I will go to after diagnostics. I will go to the matrix representation. Okay, this also looks like matrix because you remember A, the matrix A, uppercase A. Ram also said it's lowercase, uppercase confusion is there. That uppercase is the matrix, right? So there are 2 different ways to look at this. The one as systems of equation, the other one is matrix approach, matrix inverse approach. Okay, systems of equation can also be solved using inverse matrix. I don't know how many of you know that. Okay, we will come to that also. But nonetheless, the method of solving that is basically systems of equations. We saw that. We saw how to interpret the table that comes at the various values that comes out of the package, R package, LM package. Similar to LM package, there is also proc reg in SAS. Some of you might know that proc reg. Okay, procedure reg in SAS. Similar to procedure reg and LM in R, procedure reg in SAS, LM in R. There is also Python package for regression. So every language has its own package. But the point is, behind the screen, it's all about solving systems of equations. And then we saw, now we are going to see how to predict using the model. You build the model, now we want to predict, right? Because that's the purpose in the end. So how to predict? But that is very simple. Why? Because what is the equation we have here? This is the output, right? You got for the 5 observation model. That is the intercept is 2.4 and coefficient, slope coefficient is 0.6. So if I write this in an equation form, it will be like this in the following way. Okay, let me write it down. So I'm saying the equation form it is y is equal to 0.06 times, 2.0 plus 0.6 times x. That is the model. Everybody agrees with me? Okay, anybody who doesn't agree with me? ரெண்டுத்துக்குமே ஆன்சர் மௌனமா இருக்குது.
Agrees.
Yes, sir.
Yes, sir.
Agrees.
Agree, sir.
I got only 5. 6. 6 தான் கிடைச்சிருக்கு. இல்ல அங்க பின்னாடி உட்கார்ந்துட்டு இருக்காரு, குவைட்டா இருக்காரு. எஸ் பாதி தான். எஸ் சார் இருக்கேன். ஓகே சரி 7. there is one more.
Agree.
Yes.
Good morning.
Agreed?
Yes.
Okay, cool. Okay. So that is what the equation we built. There is an error component here, there, right? Where did it disappear? There is an error component there, but it disappeared because it's not really this. This is what the equation is. This is what the equation. Everybody agrees now? Actually, பார்த்தா இதான் equation. But we don't write the second part. You know why? And this is the structure part, and this is the error part. So let me rewrite this, and then I will come back to this expression. What happened to this expression? I will come back to that. Let me write it as slightly grayed out, because it's really out, but I'm right now keeping it as graying out because I want to explain that, then only it can go away. So this is same as conditional expectation is as a structure part, structure plus error in the theory, but in the actual estimation of the model, conditional expectation is only structure, because this is the assumption that this is equal to 0. You remember that? The conditional expectation of error, the errors on the average turns out to be 0. That's what this means. If you look at this one, on an average, the values can be spread around this, but has a mean. This mean means the errors will have 0 values. Everybody? 3, 4, 5,
Yes.
6, 7. Okay. Nagaraj, mollama confidently. Whoever says confidently say, because either you know it or you don't know it. Okay. புரியுறா போல இருக்கலாம் இல்ல. Okay. அப்படியா? Clear? Everybody is clear, right? So that's why the error, the expectation of the error is 0. So that's why when you build the model, error is gone. Only the structure stays. Right? So that's why this is the predictive equation. I'm coming to the predictive equation part. Remember that. That is our game, right? That is our goal. So this is what we are talking about. Rest of them don't matter. I kind of grayed it out. I'll make it more gray, so that it disappeared. This is what your model is. For every x value, I can predict the y value. Are you with me? For every x value, this is the predicted y value. For example, what is the first x value? The first x value is, here it is. First x value is -4. You agree? -2, -4, -2, 2, 4, 10. Those are the x values. Yes. So I can predict the x values are. So however many number of x values, that many number of predicted values I should have. Okay. However many number of x values, I should have that many number of predicted y values. Why is that it's not giving? I try to give this one, but it's not. Okay. Main point is, however number of x values that many number of predicted y values are possible. So what are the x values? X values are -4, -2, -4, -2, 2, 4, 10, isn't it? So what are those predicted values in this case? Can we just do that? I'm going to use the R here again. It's my calculator also. So it is 2.0 plus 0.6 times -4. That's the first predicted value. That is first predicted values. Y predicted values are the corresponding Y predicted values are given by -0.4. Can you give me another one? What is the other one? 2. I would use the word number 2. So let's just go back there. 2, that is 0.8, and then go back there. 2, that is 3.2. Go back there. 4, that is 4.4. Go back there. 10. These are all predicted values. Agreed?
Yes.
Okay, let me finish this. -0.4, isn't it? What did I do? -0.4, yeah. Minus didn't come through well. Okay, -0.4, 0.8, 3.2, 4.4, 8. These are the corresponding predicted values. That's how you do. It's very simple. You just substitute that in the function. Okay. So let's do a little bit more work, and then you will, when you repeat many times, it will become natural to you. I'm going to save all these things because I will update the file there later on. I want to talk to you about now diagnostics for developing. Oh, I need to do one more thing before I go to the diagnostics. Let me do the R square and then adjusted R square. We talked about it, but I still want to go through that one more time. Okay. It's a very important topic, you know, because that's what tells you how good the model is. We talked about it, but let's go over that with a little bit of mathematics. Okay, not this. Adjusted R square is 6974. Okay. Here is something that I want to share with you. Very important. Okay. Are you able to see this PowerPoint deck now? PowerPoint? Okay. So here is the total sum of squares. This is called sum of squares. Total sum of squares. Also sum of squares total. I don't know. SST. It should be, usually people say it as TSS. I copied and pasted here from somewhere. Total sum of squares. Okay. Is equal to model sum of squares plus error sum of squares. In other words, this is the total variance. You know, you can also, because if you put, if you want to call it as variance, you have to divide it by certain numbers here. Okay. So right now it is only sum of squares, but it doesn't matter. You can use the sum of squares to solve the problem, or you can later on you can adjust for the number of observation and the denominator. Okay, becomes the variance there. So the total sum of squares can be, this is what the total variance is, right? Total dispersion is contributed by this. Everybody agrees? Total dispersion, which is also the error sum of squares. Total dispersion is contributed by this, which is equal to, I add and subtract, okay, the predicted value in between. I add and subtract, and then now I rewrite it like this. Everybody with me? In other words, this is same as this. I added and subtracted predicted value. Everybody is with me? 1, 2, 3, 4, 5, 6, 7. Okay. I included Pomoni also in that. Yes. Thank you. So very important. The total sum of squares is split into two parts. This is konjam or algebra lam potu we can rewrite it like this. Total sum of squares is written as, this is the predicted value and this is the y bar. This is the average, right? Okay. And this is the yi minus y hat. This is the error sum of squares, right? This is called the model sum of squares. Everybody with me? The total sum of squares can be split into model sum of squares and error sum of. That's the point. But you may ask, இது எப்படி சார் இங்க இருந்து இப்படி எல்லாம் போட்டு மாயாஜாலம் பண்ணி இங்க வருதுன்னு கேட்க. That is something you have to go through. I want you to go through and then ask me questions later on. But for now, I want to take you to the statement that total sum of squares can be split into two parts. Model sum of squares. The model means it is modeling the predicted value is predicted value is the modeled value, right? So the total differences, total variation is split into the model sum of squares differences plus the error sum of square differences, or error differences squares or model difference squares. Everybody with me? I know you are still having I want to leave that as an exercise to you. Is it fair? Some work, some little bit work. Fair? 4, 5. Priya 6. Ram?
Sir, சொல்லிட்டேன் sir.
Oh, Priya. Sorry. Thank you. So take that as a message, what I told you, that total sum of squares. This will also be a question in the exam. Okay. Total sum of squares. Now total sum of squares, error sum of squares, what is the model sum of squares? It's a potential question, right? It's very simple, difference. But here sum of squares, but what if I give you variance? You have to do some little bit of adjustment. The variance refers to division denominator. Okay, total variance, total sum of squares is SST will divided by n something, n minus 2. Okay, something it will put that, and that is the total variance. And the money I will have to put something else in the denominator also to get variance explained by the model plus variance unexplained by the model. So this is what is called the R square. Because what is the fundamental problem? Please note down this. What is the fundamental problem? We are trying to explain the variation in the y value. That's what we are trying to do. We are trying to explain the variation in y value. Everybody got that point? That's what we are trying to do. In the prediction and artham, and then the value we have to predict. If y value is bigger, given the x value, we should predict the y value to be bigger. Y value is lower, given the x value, that should predict y value to be lower. So we are trying to explain the variation in the x value. Explain the variation in the y value using additional information coming through the x's. So take this point. Fundamentally, we are trying to explain the variation in the y value. It's also called predicand. Some people say it as predicand because the x's are called predictors. X's are called predictors. Y is called predicand. Predict and predicand. Okay. So our problem is always trying to explain the variation in predicand. Explain the variation in y. Out of that, the model explains some variation. So that is, if the model variation is big, that is a good model, yes or no? If the model variation is big here, that's a good thing, isn't it? Because we are trying to minimize this error. That's what it means. This is given, it's fixed. If this is minimum, this is increasing. Sorry. One second. There is something. One second. Wait.
No, it's cracking.
Yeah. One second. Can you tell me now? Can you tell me? Somebody wanted to say something? Oh, still not clean on their side. உங்களுக்கு நல்லா வருதுப்பா. Yama, perfect. Video is clean. You are able. I can hear you well. Very. I don't know what's going on at the center. Silla, central and the group. I don't know why I heard it. Okay.
Can it as a WP total variation.
Audio.
One second, pa. Riyaz is talking. So Riyaz, நீங்க தான பேசிட்டு இருக்கீங்க?
So TSS total.
உங்களோட வால்யூம் இன்க்ரீஸ் பண்ணணும் ரியாஸ். சொல்லுங்க, என்ன சொல்றீங்க? சொல்லுங்க, இன்னும் கொஞ்சம் கூட வால்யூம் இன்னும் கூட இன்க்ரீஸ் பண்ணலாம் on your side.
I got.
You understood. Okay. What is that on your side? அவங்களுக்கு போயிடுது.
சார் ஆடியோ நல்லா கேக்குது சார்.
ஓகேப்பா, இப்ப ஆடியோல சொல்லுங்க. ஏதோ கேள்வி கேட்டுட்டு இருக்கீங்க உங்க சைடுல இருந்து, என்ன சொல்லுங்க. Go ahead, talk.
Okay. The system issue அதான் சார் சொல்றோம் நாங்க.
Okay, no problem. But you got the point, right? You got the point what I was saying, that total, so total variance, that's what we are trying to explain, and that is we are trying to explain by the structure and the error. Structure and the error are independent. That's why you are able to split it into two parts. ஒரு ஸ்கொயர் டேர்ம் எப்படி ரெண்டா ஸ்ப்ளிட் பண்ண முடியும்? அது ரெண்டு பேரும் இண்டிபெண்டா, அது ரெண்டும் இண்டிபெண்டா இருந்தா தான் ஸ்ப்ளிட் பண்ண முடியும். அந்த அசம்ப்ஷன்ஸ் எல்லாம் இருக்கு, நிறைய அசம்ப்ஷன்ஸ் இருக்கு அதுல. ஆனா these are all not bad assumptions. Okay, that's fine. So
sir, voice break ஆகுது சார்.
Okay, I will slow down. I'll slow down.
Okay sir.
Okay, so I was showing you this screen, this slide. You agree with this one, right? இது ஞாபகம் வச்சுங்க.
Okay, நானும் ஜியோ வச்சிருக்கேன்.
This is contributing to the model variance. This is contributing to the error variance. These together contribute to the total variance. Because this is the variance, இல்லையா? This is the variance contributor. Okay, this is very important. So I try to explain this using a graph again here. எப்படி வருது? See, this is the total, the value of y. This is the predicted value of, on the line is the predicted value. Okay. Predicted value.
Sir, one minute ஒரு மாதிரி இருக்கு சார். நான் ஒரே ஒரு
சொல்லுங்க. Go ahead. எனக்கு சரியா கேட்கல. Kind of. I'm going to stop video on my side. Let's see whether it helps. Okay. Okay. All right. Fine. கொஞ்ச நேரம் வாய்ஸ் இருக்கட்டும், பரவாயில்ல. Let's move on. Is there any question here? ஒன்னும் இல்லப்பா, இது வந்து total sum of squares இந்த மாதிரி நம்ம டிவைட் பண்றதுனால basically what are we saying? A total variance in y is explained by 1 minute. All right. What I'm saying is, because of that split, what we are saying is that no, our purpose is to explain the variation in y. Please write it down if you want. Our purpose is explaining the variation in y, dependent variable. That's our purpose. But then, interestingly, by the structure of the mathematics, that is usable mathematics, we split the total variance into two parts: structure variance, error variance. Structure variance versus error variance. We split that into two parts, right?
Yes.
And the structure variance increase ana nalladu, error variance decrease ana nalladu, right? Agreed?
Okay.
So the structure variance is what is called R square. But not as it is, divided by the total variance, because we want to know it in terms of percentage. What percentage of the total variance is structure variance? That is what is R square. What percentage of total variance is the model variance? What percentage of total variance is the model variance is what is called R square. Yeah, everybody with me? Okay. Structure variance, what percentage it is in the total variance, that is what is called R square. Okay, now let's see the output. One example output, you know what I'm talking. We know we did record பண்ணிட்டு நான் இன்னும் ஸ்டாப் பண்ணல. வெப் கேமரா வந்தாதான் பிலீவ் பண்ண முடியுதா? சரி. ஓகே, மோர் இன்டராக்டிவ். வாய்ஸ் வரலப்பா, சரியா? வாய்ஸ் கேட்க மாட்டேங்குது.
audible.
It's very breaking. The voice is breaking on your side or on my side. I don't know. Okay, but let's keep going. So in this example, I want to share with you. In this example, R square means 0.21 means what? Solunga paakalam. Given all those interpretation, what is 0.21 means? Yes.
Structure variance.
Yeah, structure variance sonnaka nariya perukku puriyadhu. It is the variance, 21% of variance in Y is explained by the model. 21% of variance is variance in Y is explained by the model. Yeah, total variance or Y, but you have to say Y. It is our dependent variable. You have to say that. It is better to say dependent variable. It's more expressive. Y na yarukku theriyadhu. Y na enna theriyadhu. What is Y nu right? So dependent variable is better. 21% of variance in dependent variable is explained by the model. But here is the problem. As you increase the number of variables, this will increase. That is not good. That will lead to overfitting. So we have a formula that adjusts for the number of parameters, because the more the number of variables, you have more the number of parameters. The more the number of variables, you have more the number of parameters. So they adjust the number of parameters and they recalculate that, but it so happens it doesn't affect in this case. Okay, because there are not too many parameters, it doesn't affect. So it is almost the same. But here is, the formula for that. I'm going to give you the formula now. Okay. But just the formula is only for knowing sake. You don't have to do all these things. Your system does it for you, right? Isn't it? Your system does it for you. So here is the formula. Very ugly looking formula maybe. Look at this. This is, now I am going back to what is R square? 1 minus sum of squares due to error divided by sum of squares of the model, full model. This is also called the total sum of squares. Are you with me? This is R square. I can say it differently. Instead of saying model sum of squares divided by total sum of squares, or model variance divided by total variance, I can say error variance divided by model variance, or the error variance divided by the total variance, because in 1 minus potadunala. Are you with me? Everybody with me? I mean, I'm just, because people do all this, I can rewrite this in a different way. They try to confuse you, right? I will try to confuse you differently. Hopefully, let's see whose confusion is more. So R square is, I told you this, right? Model sum of squares divided by total sum of squares. I told you this, right? This is same as, I can also write it like this. 1 minus ESS, error sum of squares divided by total sum of squares. Agreed? Everybody agrees? That's what they did here. They are doing it here. Everybody agrees? Yes or no? I can't hear you. 1, 2, 3, 4, 5, okay, 6. Everybody. And I say pictures. Okay, everybody, I agree. So if you don't know, it is your job to bother me. Is that a deal? That's better, I think. I don't have to ask you. Do you agree? Do you agree? Is that a deal? If you don't know, it's your job to bother me. Like Ram, he will hold me. And the Mari puts, you have to hold me and then say, I don't understand this, I don't understand this. Right? Okay. Punmani, are you there? Agree?
Yes.
Okay, cool. Now, so there are different ways they write it, so don't get confused about it. But the main point here is that we are just adjusting the parameter. You see this one? As the parameter increases, denominator increases. If the denominator increases, this is going to, the impact is going to decrease. Okay, so but this is the R square. That means this is the error part of it. No, this is the model part of it, right? 1 minus R square. We are putting it as 1 minus R square sum of squares. Okay, so this is the error part. The main part here is that as the number of parameters increases, the denominator increases. So this increases. This increases means this decreases. Adjust R square decreases. As P increases, this is what my point is. If you don't understand that, you should ask me. But as P increases, R square, adjust R square decreases. Right, Riaz?
Yeah.
Okay, cool. As P increases, I think I'm doing too much maybe. I don't need to do that. Yeah, sorry. As P increases, something is decreasing. What is that? You already know the answer. Adjusted R square decreases. But as P increases, something is increasing. What is that? Regular R square is increasing. You agree? Regular R square is increasing if P increases. Adjusted. Everybody with me? So far so good. So I wanted to finish that one. That is done. Now the final part I want to explain is we talked about
What is the difference between R square and adjusted R square?
What is the difference?
Between R square and adjusted R square?
Yeah. You want to know the difference between those two. I told you, look at this expression here.
Interview question.
Yeah. Interview question is Nachama. The formula is this. First of all, we know that 1 minus R square is the error sum of square related, right? We kind of talked to you because I talked to you through this, right? So there is a mathematical process that which gives you adjusted R square like this. The purpose of adjusted R square is to make sure that you adjust for the number of parameters, because if you don't adjust for the number of parameters, R square will continue to increase and it will take you to overfit the model. So by introducing overfit means you will keep on increasing more and more useless variables. That's what overfit means, and it will not help you in the prediction, but it will still show you incorrectly that you are building a good model, because you remember, as R square increases, it is a good model, right? That is a measure of goodness of fit. That's a measure of goodness of fit of the model. So increasing R square is good, but there is a caveat. As R square increases, the model predictability of the model becomes less, not valuable, because there is a bogus predictability increases. It's not real predictability, there is bogus predictability increases because of the nature of the formula. So adjusting for the number of parameters, adjusting for the number of variables is a constant problem in model building. Understood what I said? Adjusting for the number of parameters is a constant problem. It's a regular problem in model building, because the more the variable you throw in the model, you are more likely to get a better goodness of fit. But just the measurement goodness of fit alone is not good enough. Predictability should be good, but it won't predict, because your variance, error variance, there is, what is called the model. Model gives you undue confidence to you, because R square will keep increasing as you throw in more and more variables. So in order to control that fact, you create this adjusted R square, which is decreasing as the number of parameters increases. So there is a kind of best case scenario where you have to stop adding more variables. There is a best case scenario where you have to stop adding more variables. Agree? Logically only I can explain these things, because there are a lot of mathematics behind it. Can it? Oh, you can't type also. Okay. So it's okay. I'll stop, because your video is not feeding well, and I'm going to stop also my video for now. The freeze item and very frustrating. I'm not getting good speed. Maybe I don't know. Okay. Are you able to hear me? Sorry guys. Are you able to hear me?
Yeah.
Okay. You are good. Your video is perfect for me. It's really It's really somebody is okay. All right. So I want to stop there, and then I want to take one more part, diagnostics for developing a good model. Now we are ready for that. Okay. I'm going to post this document to all of you. Diagnostics of regression. This document. Okay. Regression diagnostics in R. I'm going to post it. And before I do that, I can do that. I will do that after the class is over, but I want to open it up for some work with R. How about that? Let's open this.
Okay.
இல்ல தெரியல நடுவுல விட்டுட்டாரு ஒண்ணும் எதை பத்தி சொன்னாருன்னு தெரியல.
I am coming back.
Okay. Sir, next class, sir.
Welcome.
Okay. No problem. No problem.
Continuity இல்லாம இருக்கு sir.
So we have on Wednesday, sir.
I will confirm some information for you. Okay. It came back. I will confirm the information for you all. Okay.
Okay, sir.
So next class we are going to do diagnostics.
Sure, sure.
That means how to develop 1 minute, how to develop the idea that we are doing a good model. How do we make sure we are doing a good model, right? See, we know how to determine whether a model is good or not, but what is the process of leading to the good model? It's not enough if you just throw in and then LM gives you the output. It's not enough. You will see what those issues are. That is what we are going to do. Yeah.
You mean to say tuning a model?
That is correct. Exactly. Tuning a model. But then tuning is a very broad word. There are a lot of things that go into it. We will say diagnostics, which includes, which has the ideas about tuning. But tuning means more. Even when you are trying to use the R square to fine tune the model, it's tuning. Okay? All right. All right, everyone.
What is underfitting and overfitting, sir? Overfitting or underfitting?
We don't want to underfit. Also, we don't want to overfit. We want to do the best fit. Right?
Definition is overfitting is that.
Overfitting is where what happens is that the bias and error, which is another topic which I haven't talked to you yet. In a general term, the bias and error. Okay, there are two parts: the bias part and the error part in fitting a model. That's another way of looking at the goodness of a fit. Okay, bias and error. And I'm going to talk to you about bias and error, but I'll show you today one slide which talks about bias and error. Look at this slide. This is called low variance. Okay, I will stop with this. This column is low variance. This column is high variance. Okay, this row is low bias. This row is high bias. Look at the picture here. The variance dispersion among the observation is less. Do you agree?
Yes.
Here also dispersion around the observation is low here. Okay, but this is on the target, bullseye. But here, very away from the target. It's a high bias, but low bias. Low bias, high bias. But both have low variance. Agreed?
Yes.
Here, this is the whole column is high variance. In other words, dispersion is too much. Even though it is on the target, average is on the target, dispersion is too much. It's less reliable. Here, not only dispersion is high, but its bias is also high. It's not on the target. If it is not on the target, it's called bias. If it is on the target, it's called low bias, no bias or low bias. Okay. If dispersion is too much, it's called high variance. If dispersion is less, it's called low variance. So the best thing to achieve is this. This is what you want to achieve. Low bias and low variance is what we are trying to achieve. So what happens is, if there is a overfitting, then the bias increases, and the prediction will become bad. So that's why your overfitting is not good. With me? But I have to give you more ideas into it so that you will buy into that idea better and better as we go along. So overfitting is not good, underfitting is not good. Underfitting means you have opportunity to improve. If you do overfitting, you have opportunity to improve in a different direction, that is to knock off unnecessary things. If you have underfitting, then you have opportunity to increase by adding more variables, correct variables. Yes? Does make sense? Okay. But I don't expect you to know thoroughly now, but we have to do few more. For example, I want to share with you this graph also. So let me finish this graph. It is easy to follow, right? With this, it will be the last one. How about that? Okay? This is the last graph. Very easy to understand. See, I have two variables, happiness and wealth. This is 8 observations, right? Happiness and wealth are like this data, and then this is the line. So here there is an opportunity to improve, that is reduce the error, training error. Also the bias you can reduce. Now I can improve it by building a nonlinear regression. See, this is a linear regression, this is a nonlinear regression. But I can also improve by piecewise linear. Every piece is connected together. So this is a perfect fit on the training side. But if you apply it, that means the lowest error, right? But if you apply it in the real life, this will not hold good. This will hold good. This will also hold good, but it has a potential to reduce the error. So far, so good. So model complexity means more number of parameters. That's what complexity means. Complexity by definition means more parameters.
More parameters means more variables, you think?
More variables, yes. Yes. Okay.
It's a multiple regression, right?
But then that doesn't mean that there is a one-to-one corresponding. If I have 10 variables, there are only 10 parameters. It doesn't mean that. It can be 20 parameters, because you can take all combination of variables and then introduce that as a new variable in the model. So if you have only 5 variables, doesn't mean only 5 parameters. Well, that is true only in the case of linear. Yes? Okay. No? Okay. Only in linear models, if you have 5 variables, you will have 5 parameters plus the constant parameters, 6 parameters.
Okay.
Only in linear. If you have 10 variables, 10 plus 1, 11 parameters. But for non-linear model, you can have any number of variables. I can have, literally speaking, I can create 1,000 variables in all kinds of polynomial combinations. X, let's say X, Y, no, X1, X2. And then X1 times X2 is another variable. X1 square X2 is another variable. X1 times X2 square is another variable. X1 cube is another variable. X2 cube is another variable. X2 200 is another variable. Any number of parameters in a non-linear way. So that's why I say more number of parameters. It's a little bit more than the number of parameters. I mean, it's not just a number of variables, because we can also create more variables out of it. I'm going to stop here.
This is also called multiple regression, right?
Huh?
This is also called multiple regression, right?
Yeah, more number of parameters when you put in, it's called multivariate model. I'll stop there, because it's multiple regression. Yes, exactly. So we will stop here. We will continue next time. Diagnostics. Okay. Everybody with me?
Okay.
Good night, everyone. Thank you very much. Have a great evening. We'll meet. I'll try to allocate some time during the week.
Yes. Thank you, sir.
Thank you. Bye.
Yeah.
Bye, sir.
Bye, Riyaz. Bye, Punmani. Bye, everyone.
Thank you, sir.
Bye. Bye, Punmani.